Today we will be having the second round of technical sessions in the Vedanta auditorium and the parallel session on risk management in the Vishwasarya first floor. The first session 5A will be on contractual issues, and I'd like to introduce you to the chair and the co-chair for this session. The chair for the session is Shri Arvind Kumar Jain, Vice President IRC and ENC UPPWD. The co-chair is Mr. George Mavroini, PI-ARC TC 404 member. I request the chair and the co-chair to kindly come up on the stage and proceed towards the high table. I'd like to invite Shri Sanjeev Kumar, Director IAHE, to kindly come up on the stage and felicitate the chair and the co-chair. Thank you so much, sir. There will be three presentations by the experts, the first being on the extraordinary geological occurrences and contractual issues by Professor Arnold Dix, President ITA. The second will be on the challenges and risk management, tunneling and underground constructions by Colonel Parikshit Mehra, Indian Army. And lastly, the risk management plan for underground road tunnels by Mr. A.K. Srivastava, former ADG MORTH and convener H10 IRC. I request all the presenters to kindly head towards the high table. With this, I hand over the procession of the conference to the respected committee. Thank you so much.
Very good morning to all. And at the outset, I extend my very warm welcome and hearty greetings to you all. My co-chair, Mr. George Mavroni, and distinguished presenters, Professor Arnold Dix, Colonel Parikshit Mehra, and Mr. A.K. Srivastava, ADG, retired MORTH. As you all know that this very session, the very first session of the day 2 of this international seminar is on contractual issues and risk management. For any infrastructure project, as you all know, that the technology and robust engineering is very, very vital to make it succeed. But equally important role is there of the contractual management, the contract document and contract conditions. The role of a fair contract document becomes even more crucial when the project is of complex nature, like tunneling. So more complex the project, and then more important becomes the role of contract. As we all know that subsurface projects, the underground projects, are full of complexities and uncertainties. In fact, they are the blind projects. So the risk assessment, the risk management, risk allocation is a very, very important issue in the underground structures. And it becomes very important and very, rather it's very essential to integrate the risk management and risk allocation to the contractual issues and contract document. Because until we integrate these both, then we cannot succeed in the project. Most of the projects fail or they get delayed because of the poor contract document. So the contract document should be well written, it should be unambiguous, and the assessment of risk and risk management and its allocation to the different stakeholders should be very clear. So with this objective, this session we will start, and I hope that these presentations on the risk management and contractual issues will be very much enlightening on the subject. So with this, I hand over to my co-chair, Mr. Mavrani, for his remarks and conduct the session.
Oh, thank you. I didn't really have much to say, apart to agree with what Ravinder's already introduced to the group here today. We know from the experience of excuse me, many large projects around the world that it's so fundamental to success to have the correct risk apportionment to the players within the contract that can appropriately manage those risks. And if they're incorrectly apportioned, then we get into many contractual arguments, and that can lead to the downfall of projects, which is a real tragedy. So the planning of the risks and the apportionment of the risks is critical for project success. And I look forward to listening to our three presenters today on the topics of contractual issues and risk management for tunnel projects. Thank you.
Yeah. So to start with, I would like to invite Professor Ronald Dix, President ITA, to present his paper on extraordinary geological occurrences and contractual issues. Professor Ronald Dix.
Suprabhat Dosto. Ladies and gentlemen, good morning. I'm talking the law, I'm talking contracts, and it's early in the morning. This could be a disaster already for a group of technical people. I have a slight technical question for my friends in the audio-visual. I was promised a remote control clicker. So, here is my clicker. Okay. So now, because it's early in the morning and I have spent 33 seconds of my 22 minutes, I'm about to change how I do this. Is it working now? I'm stepping away from behind here. And the reason I'm stepping away from behind here, and can I just ask, how many of you have actually studied law? Just if you could put your hands in the air. So 1, 2, so 3, 4. Okay. You four, you're the judges now. Okay, I can talk to you in a minute about it. How many of you have children? Right. What is it that children, no matter where they're from, everywhere in the world, complain about the most? It's not fair. Mum, Dad, it's not fair. Am I right? Your children, this is a common, in whatever language, it's not fair. So how can it be that our children say it's not fair instead of there's a fault line over there? I think that'll be difficult. The portal should be over there. I suggest to you the reason for that is because fairness is something that we all are born with an understanding of. So, how many of you think in a contract in underground works here in India, it's been unfair? Got a few hands getting up? Okay. Any contractors who think it's been unfair? Your clients will close their eyes, okay? So, are there any contractors here who are going to say unfair? Can I ask, I'm going to come down, because I think I know the answer to this. I'm going to guess unfair because you felt you did so much honourably and you didn't get rewarded for it as you thought. Is that the unfair?
Yes, yes, it is unfair that whatever we do more than our capacity sometimes, but when you don't get the return reward in the same manner, then yes, it's unfair.
So contractor is saying, sometimes I feel it's unfair because I've done all this work and I haven't been rewarded for it. Do I have a client who thinks that sometimes the contractor is unfair, wanting too much money for the work that they've done? Yeah? There must be. Yes. So your client, but the evil contractor sometimes wants too much money for the work that they've done, correct?
Correct. Yeah, that's correct.
So we started off as children all telling our parents that it's unfair, and already within just 2 or 3 minutes we have contractors saying it's not fair, we've done too much work, clients saying it's not fair, you want too much money for not such much work. What about people? What about community? Is there anybody here who wasn't involved in the project, but at the end you feel it was unfair because it was too slow, it ruined your roads, something is unfair? Sir, you're nodding. Is this the case for you? You felt the project was unfair in the project? Yeah? Okay.
There are many projects which sometimes get delayed, and as a community, as a common man, one feels he doesn't know the main thing, that who is at fault, whether it is due to contractor or whether it is due to engineers. But as a community, as a common member, sometimes we feel that this contractor is not being completed timely, so it is unfair to us. It is unfair to the society. Yes.
And do we have any politicians in the room who were promised the project for so much money on time and it didn't come, and they're feeling it's really unfair because they've put their political career on the line? Any people in a political position who thought it was unfair? Okay, even if they did, they're not going to put their hands up because the media might be here. So why would I start a presentation like this? I'm a barrister as well as being a technician. I think contracts for our underground projects are often unfair. Often. We don't want to be enemies of each other. We want fair contracts. So, at the ITA, the International Tunnelling and Underground Space Association, and can I say this is very good, I get to walk over and look at my own clock. So if I don't want them to stop me, I'll stand like this so they can't see the time, okay? At the International Tunnelling and Underground Space Association, we want underground solutions for a better world. This is actually what we're trying to achieve. And we believe that underground solutions can help make a better world. But if we're going to do that, we also believe the way we contract has to be fair, because otherwise there'll be too many losers. And the people who win won't tell you who they are. So there's the potential for these projects to go really bad. So we're consultative status for the United Nations. We've been around a long time. We advise the United Nations Economic and Social Council. We're into that. We see sustainable tunnelling and underground space includes the contracts. It's not sustainable, our industry, if the winners and losers are too big. It should be fair. And what is it that winning looks like when you're building an underground project contractually? Well, and I'm open to suggestions, but the clues are on the window there. People want to know how much it's going to cost. People want to know how much time it's going to take. People want to be sure it does its job. And people want to be sure of the quality. It's just like any other thing that we build as or buy as a consumer. And to understand what fair contracting is in a global sense and what it might look like in countries that are not all the same, I've developed close relations with the International Monetary Fund and also the World Bank. And my friends, they also want to see it fair in contracting, because the money that comes into their funds comes from about 170 member nations, and they want most of that money to build the infrastructure. And the best way to do that is fairly, so that you get paid for what you do, you get what you want. And to do that, we need new techniques. And there's a saying in English that you can't find new land with an old map. And so you can't get a different contractual result unless you have different contracts, because it's always going to end in tears if you have contracts which are unfair, no matter what your intentions. So what the ITA did was we tried to understand what does a good contract look like, and we went all around the world looking at those, and we decided that there were lots of complex technical, scientific, geotechnical, social, economic dimensions to it. We noticed a phenomenon which I'm sure you're aware of, and that is that there is a push generally internationally towards unfair contracts, because unfair contracts is actually really, really naughty fair for one person and really bad for someone else. That's not fair. That's one-sided contracting. We found a very naive view around the world that ground condition risk can be absorbed in the contractors because the contractors are rich, because the contractors are some evil, large, predatory monster coming to eat all of the money of your country. Wicked, terrible things they are. A common view. Unfair is normally when the lawyers who are on the side of the client are looking very happy. This was one of the things that we observed. But can I tell you, this style of contracting is not what contracting is meant to be. Contracting is an ancient form of agreement between people. And in its ancient form, it is meant to be fair. Because if it's not fair, we lose faith in the ability of us to interact to achieve great things. For me as a barrister, when I colour my little curls a little white and I do the barrister thing, my duty is to the court, primarily, even above my client, that what I do is fair and just. So ITA went off and approached many organisations around the world and asked to help us create the beginning of what would be more fair for the underground. And over a period of 5 years, with a collaboration between 40 countries, FIDIC, whom you know because you use your FIDIC books here on major projects, and ITA produced the world's first ever joint FIDIC-ITA document, which is the Emerald Book. And that contractual arrangement is now used by the World Bank for hydro. And it looks something like that. But looking at it doesn't tell you anything about what's inside. What the FIDIC book does is provides an example of how you might do it. I am not here saying you must use the FIDIC book. I am saying here is an example of an advanced contractual arrangement which deals responsibly with ground condition uncertainty. I'm not saying it's the best. I'm not saying there'll never be better. But at the moment, this is the most sophisticated version the world has. Key features. There's a system of document priority. Contract data coming first. Completion schedules. When is it going to be done? Very high. Schedules of baselines. Geotechnical baseline reports. Employers' requirements and general conditions. There are events which are very serious under the contract which trigger certain actions. The contractor is expected to do the job the contractor said they can do. So if the contractor fails because they say, I am the best contractor at Himalayan construction, and they get their workforce there and they're all scared of heights and don't like eating Indian food, well, they lied to you. And for that, they will be punished under this style of contract. The contract does not talk to lawyers because it talks to the engineers. So if there's a problem, it's referred to the engineers to solve the problems. The engineers have the key roles under the contract. There's an internal dispute avoidance board so that within the contract you choose the people to fix the problems that as they happen come along. There's a series of discussions about the purpose, the key personnel, special requirements, scope, and even preliminary design. There's a geotechnical baseline report describing the surface and physical conditions that are the basis for the excavation and lining works, driving the construction, driving the expected reaction of the ground, and describing the allocation of risk between what was expected and what was not. This GBR is sometimes misunderstood. No one is promising that this is what will be down inside the mountain. What they're promising is this is the basis from which we measure the costs if it is different to we expect. So there can be a range of different support classes depending upon the behaviour of the ground. That can be agreed in advance. So we don't have a fight about the cost of the support. Instead, we have a fight in the tunnel between the geologists about the way the rock is actually behaving. This is much better. Lawyer fights are expensive and cause too much tension. Fights between engineers are often bloody, but are honourable and resolve matters between engineers as engineers, which I much prefer. So, if the GBR conditions are encountered, not negotiably, the project has to meet its schedule and technical deliverables. Okay, and I'm down to 3 minutes, self-regulating. So it's got to be performed correctly. Time for completion must be done on time, high priority. And you can only get extensions if there's exceptional conditions like really, really bad climatic conditions, which could happen here. Some problems like a epidemic, not that that would happen. I can't imagine an epidemic ever affecting us in our industry. It's completely unimaginable. Unforeseeable shortage in personnel, just things like that, but very rare. And of course, the project can be accelerated. So, under this arrangement, if the project suffers because circumstances aren't as expected, it's already been agreed what we're going to do with price and cost. So it's no longer a legal dispute, it's an engineering problem. And these problems can be resolved in terms of changes of time. It can be resolved in terms of payment for different excavation and lining works, depending upon the physical conditions, the behaviour of the rock, and what that means, as agreed within the project. And you must make your claim within 28 days of there being a problem, or under this contract, there's no problem. So you can't keep your dirty claim hidden for the end of the project. You actually have it up the front. So conclusions. Right on time. Our projects are typically GDP impacting projects. They are on national economic scale in terms of cost and in terms of what they deliver for our economies. Lump sum fixed fee full risk transfer is the most common type of contract and most typically ends in tears with an unhappy client, an unhappy contractor, and just a lot of unhappy. And after all, we as technical engineering people, we like lovely projects being delivered that show off to everybody how awesome we are. This new Emerald Book marks a change in the global recognition of the importance of ground conditions in apportionment of risk. The mechanism might not be perfect, but it's a step in the right direction, a step towards greater fairness. And it's a framework which contractors are rewarded for the good work they do and punished for incompetence, and the employers and the community gain the benefit of that. And that, my friend, with 13 seconds to go, is my presentation and introduction into contracting. But I have one more thing. I have to warn you. In my pocket, I have chocolates. So if you ask me questions later, I'll give you a chocolate. Thank you very much, my friends.
Thank you very much, Professor Diggs. You presented very well, and my request to the audience would be that you please write down your questions if you have any, and we will take up the questions at the last of the presentations. Now we move to the next presentation, that is on challenges and risk management in tunneling and underground structures by Colonel Parikshit Mehra. He is from BRO, Border Road Organization. This organization, as you all know, that works for very difficult projects and the projects of national importance. So I invite Colonel Parikshit Mehra for his presentation.
Thank you, sir. And so, it's actually an onerous task to do a presentation after the president of ITA, and the canvas that he's covered, probably what I'll try and do is cover a very minuscule part of it. So let me just go back to the start of my presentation. For some reason, we are in the middle somewhere. No, it's not. Yeah. All right. So yes. So where does the first thing is, I believe with risk is, where does the risk get in? So the risks are getting in the first stage itself. When we are deciding the environment as to where we are going to work. When we talk of metro, systems or probably subways, we're talking of soil. These are shallow tunnels. When we're talking of road, rail, hydro tunnels, we generally in rock, and there would generally be deep tunnels. Now, these are two different ball games. Unfortunately, we have these formulas going for us in our industry, which is one formula fits all. It doesn't work that way. So if this decision isn't taken right as to how do we want to analyze the ground itself, we will induce a lot of risk in the system before we even start the work. The other aspect is obviously the choice, as to how do we want to excavate that tunnel. Do we use a mechanical mean? Do we go for TBMs? Do we go for road headers? We have mixed experiences with TBMs in deeper environment. Why is it so? Are we exploring enough? And does the kind of heterogeneity that we have in the Himalayan region allow for these TBMs to function? Or are we even picking up the right TBM or the right EPBM? This is something which will induce the risk right away. With drill and blast, yes, it's much more flexible, gives us that kind of a flexibility, and probably that's why it's popular. So picking up these means and picking the right choice is important. Otherwise, before even having started the project, we would have induced risks in the system, which all of us as clients or as contractors and engineers will have to deal with. So the geotechnical environment has an impact on the risks. Obviously, with shallow tunnels, I'm sure that my friends, if they're from the metro systems, would generally disagree. But it's easier exploration, slightly lesser risks. It's easier to map. There is scope for damage control because you can probably dig out a DBM, you could do a shaft and take it out somewhere. It's semi-infinite, nearly isotropic in most cases, but for the utilities. But as we go into deep tunnels, what we are talking about today, about road tunnels, about highways, this is where complex exploration and accessibility issues are there. We know that our machines will not reach everywhere. We can't have a borehole going in everywhere. There are large unknowns, there are higher risks, and there is extreme heterogeneity. So we need to work around that, and we need to find out a way as to how, as clients and contractors, we find a common path and deal with them. But to add to it is the geotechnical melange, where you have the rock structure itself, you have the in situ stresses, which may vary, you have hydrogeological conditions. Only to define the rock structure today, we have these varying formulas that we use. We use Q and RMR and GSI, probably in a lot of times not even realizing the basis of these researches from where these empirical formulas come in from. So this adds to the challenge. Add to it the Himalayan geology. We are on a subduction zone, younger mountains, dynamic movement, probably rigid movements also come into play. So that adds to the risk and to the unknowns in the system. The solutions are many. As I said, we are so used to using these charts, whether there are charts for Q, whether there are tables for RMR, whether there are GSI values, whether there are other formulas. But what we need to understand is that is not what is going to help us. Finally, what will help us is what we discussed probably in the last session yesterday. I think most of you were here yesterday. Scientific exploration, geophysical methods, and intrusive investigation technologies are important because we need to investigate. We need to know what we're getting into before we get into it. We need to have more geomechanical characterizations where the behavior type and we need to divide that mass into probably the support type so that the contractor, before he begins the work, knows what he's getting into, and all this has to become part of the tender. There has to be a robust preliminary design. There has to be a tender with a baseline. We discussed enough about the baseline also in the previous presentation. And probably what is sadly missing is that we need to monitor and optimize. We are in an environment where we can never know 100%. So investigation goes on even when we are executing. So monitoring practice is an extremely important practice. And we need to keep optimizing our supports as we monitor the deformations so that we can do this practice optimally. We are talking about how to reduce cost. One of the ways to reduce cost is to put the support that particular strata requires or that particular geology requires. In most of our contracts, how we are executing today, we tend to define a support class and we end up putting X number of rock bolts where they are sometimes not even required. So in very competent rock also, because it is contractually required, we end up putting supports which are not required. So this is where we can optimize through monitoring. We can optimize and put only the supports which are truly required by the ground, and that's the only way that we can save costs. With this, I'll come to Atal Tunnel as to what happened, and you know, we had a great experience with the Rohtang Tunnel, or the Atal Tunnel as it is called now. You know, it took us 10 years to construct the tunnel. Just to give you a background of people who would not be aware, is that this tunnel is one of the 4 tunnels which was to come on the Manali-Leh route, the first tunnel, and it was prudent that we start with this. After that, the fact that we've now done the excavation of the tunnel and we've completed the project, you know, we've opened up the valleys ahead of us, and we are already in advanced stages with DPRs for some tunnels. We've already uploaded our tenders. You know, there is another road called the Neemupadam Darcha Road where a tunnel called Shinkula is coming up. Border Roads is already doing it. The tender is uploaded, and hopefully in the next coming few months we should start work there as well. So this was extremely important for us to be able to connect Leh, you know, all weather. The tunnel was a 9 kilometers tunnel. Both portals, the north and the south, were more than 3,000 meters in altitude above the MSL. You know, the tunnel reduced 46 kilometers of distance and almost 4 to 5 hours of traveling. So it was a game changer for the area. You know, it's a 10.5 meters width with a 8-meter carriageway and footpaths on both sides, and we had an overhead clearance of 5.5 meters, so that all the equipment which would be required either by defense or for development ahead could go ahead and cross the Rohtang Pass all weather. This is the cross section. The interesting part is it's a single tube tunnel. The little box that you see at the bottom is the escape tube. This was connected by the main tube with the access cuddies every 400 meters. And due to this particular cross section of this being a bi-lane tunnel, we were sometimes doing excavation dimensions which were more than 14 meters. So, you know, 14 meters excavation in the Himalayan rock with such great heterogeneity, you know, an investigation which could not have gone on top because we had overburden up to 2 kilometers. This was challenging. You know, there was generally mica schist, there was migdotite, there were phyllites. We were very happy if we got quartzite, you know, and obviously in no order whatsoever. You know, it would be stratified in so many ways. We started working on the project with the design matrix using the Q values and the overburden values, and based on these we had 7 support classes that we had defined when we started the project, and to be very honest, it all went well for the first about say 500 to 600 meters when we were working with these kind of supports, and we could always fit into one of these. We were working with a FIDIC Red Book. It was a BOQ contract. The monitoring agencies were obviously the Border Roads organization, the DG being the employer, and we had a chief engineer stationed there close to the project site who was dealing with the contractor through the authority engineer. We were there, so to say, for ensuring that the funds are available, and you know, we had a designer with us with the FIDIC Red Book. It was the employer's design, so he would give us the designs and we would issue them to the engineer, and the engineer would finally end up, you know, giving instructions to the contractor to work ahead, and that's how this thing functioned. You know, there were peculiarities being that Rohtang Pass is closed for 6 to 7 months in a year, so we could work only from 2 portals. The south portal, which was accessible through the year, but the north portal on the other end towards the Sisu side, people who've seen it, would be accessible only for about 4 to 5 months in a year. So we could, and it was one tube. So we only had 2 faces to work with. There was no escape tube. There was no chance that we could have had an adit. So 9 kilometers with 2 faces is what we were working for. And the highest overburden reached almost 2 kilometers. The alignment was below glacial lake, so there would be snow accumulation on top. There would be snow accumulation on the portals as well during construction. It was through crystalline thrust, and there was varying geology. Obviously, we got a lot of variations from what the rock that we predicted. Thankfully, it was BOQ, and we were instructing through the engineer supports which were required. That went okay. The emergency egress tunnel, as I said, was built into the main tube, and that is what made the cross section big. But what hit us was the Seri Nala fault zone. We have reason to believe probably this was one of the largest shear zones seen by a highway tunnel in the world. This is just a small graph of the progress that we were getting from South Portal. So somewhere around 12th of January in 2012, you see that all of a sudden the progress drops. So this is where we hit Seri Nala. But at 1900 meters change from the South Portal, we hit the Seri Nala fault zone, and it continued till the change is 2462, and it took us 4 years to get through this 587 meters. It wasn't that we were not expecting the Seri Nala. We knew that there's going to be a fault plane or a Nala on top of the tunnel. It was 400 meters above us, and we were crossing it at an oblique angle. And it wasn't as if we had started excavating in the Nala. You see there was never less than 200 meters of overburden between the bottom of the fault plane or the water channel and the tunnel. But still, because of the peculiarity of the fault zone, the water would permeate into the tunnel, and we had major inflows of water and a lot of muck flows. Again, we use these terms slightly loosely sometimes, but it was squeezing. It was high stress, poor rock, and there was a lot of squeezing. We had major ingress of water, sometimes reaching 80 to 100 liters per second. And when I say per second, it is 80 to 100 liters per second, and it would go for days together at that time. We had muck flows, numerous of them. We tried to make check dams, and the muck would just flow over them, and we probably, none of us there as clients, the authority engineers, the designers, the contractors, we really didn't know what to do. We tried a lot of things. We did chemical grouting, didn't help. We tried to do a pilot tunnel, but the pilot tunnel also collapsed. We did micropiling on the ends with some partial success to start with, but we've had deformations more, ranging up to 2 meters. And we had to finally suspend work because it became unsafe. We tried side drifts on both sides, supports, and these would also collapse. We had a lot of experts come to us from various organizations, and it was, there were inputs that we got, but a lot of people on the side believed that we should divert. And had we diverted the alignment itself, to cross the fault zone in a perpendicular manner, probably we could have gone in faster. But then, obviously, you can't ventilate a tunnel like that. You can't have traffic going in with an acute angle inside the tunnel. So, thankfully, we decided against it. We went up. We actually, a team of the client, the contractors went up on top of the hill. We trekked up. And we actually did a survey to map as to how we were juxtaposed with the fault zone, and we realized that we had 400 more meters to go, and then we would get into competent rock. So we reduced this, and that's how we finally persevered with the alignment. We did a core drilling to find out, at certain changes, we started getting some amount of rock in the RQD samples as we were doing horizontal drilling and finding samples, and we knew that we'd get through. By this time, we'd gone back to the test book, probably taken the right decisions. We started doing sequential excavation under proper pipe-proof supports. There were 114 mm pipes, sometimes double layer. What you see on the top left is a double layer pipe proof. It is 114 meter diameter pipes, 15 meters in length at an angle of 5 to 8 degrees, and we had 114 such pipe roofs, one after the other. And we finally ended up doing a sequential excavation with 1 meter by 1 meter panels, and doing temporary inverts, and that's how we got through in the end. So from December 2011 to what you see, the soft soil coming, to December 15 is when we started seeing the hard rock come out of the face again. And the impact was this, where we did just 557 in 4 years. We did more than that in the next 4 months. In fact, in those 9 kilometers, we took 4 years for Serinala and 4 years for the balance of the tunnel. So this is an impact that an EGO can have on a project. Then we went ahead with the deep invert, to get into a geomechanical shape which would be stable, and we had to put bridges to keep working concurrently also with the activities ahead. So we launched bridges inside the tunnel so that we could work on the deep invert and also work on the activities ahead, doing a lining for the balance part of the tunnel. So tough, and all these decisions were being taken when we weren't sure how do we contractually handle it. There were other challenges. There was high stresses due to overburden, temperatures touching 55 degrees when we did the breakthrough of the tunnel. We had to do initial surveys, lots of things. So what are the contractual issues? I come to the moot of my presentation. I've got 4 minutes to go. I'll try and cover this. Now what we need to understand as probably as clients and as an industry as such is that tunnel projects have high establishment costs. When all of this is happening and a contractor is only excavating 500 meters in 4 years, he's incurring costs. How do we take care of those costs with a FIDIC Red Book? We had no idea. These overhead costs were obviously time related. Any event which changes the critical path will impact the overall cost of the project. The FIDIC Red Book did not cater for this. Performance risk as contractors, we totally agree, as you said in your first presentation, but the client has to own the risk of the ground, or partially, if not whole. So the concept of time-related costs needs understanding for better contract management and participation by competent firms, because if we do not do that, if we do not cater for these costs, then we will never have competent contractors come and work with us, because, if God doesn't play dice, the tunnel engineer won't. It can't happen. And what we don't realize at clients a lot of times with those lump sum contracts is that if a contractor has come into play, he has already loaded the cost there. So you have paid that cost of risk even before it got actualized. Only then would a competent contractor work with you. Because if there are unknowns and the unknowns will not be, and the risk of those unknowns will not be shared by the client or by the industry, then these contractors are going to load that risk into that cost, and they're going to charge you that cost even if that risk does not actualize. So we are saving nothing. If we think that we are saving money by doing so, no. We are actually giving the money to the contractors even if the risk does not actualize on ground. And so what we end up doing was, we had a twofold challenge. We had to establish the TRC cost. It wasn't built up. We had to determine the time for which TRC will be applicable to the contractor. We evolved the TRC cost based on the actual cost being incurred by the contractor. He was good enough to come up with data with us. We got it audited, and we calculated the costs, the percentage of his overall contract cost to be, that would be the percentage of his time-related cost, the indirect and overhead, and then the time applicable. Finally, what we ended up with, it's slightly complex, but what we ended up doing is we isolated the indirect costs from the total cost of the project. And we came onto a figure, ballpark, say 25% being the indirect cost. And at every stage when we would make the payments to him, if the contractor was working in time as per the extensions given to him, we ensured that he also kept getting the indirect and overhead costs. And we devised this formula to ensure that there is cash flow on the site, even when the contractor was struggling with very poor ground. And then a multiple number of activities after we came out of this area. And it is because of this that we never stopped on the site, probably for that 15 days of suspension from one end. And we kept paying the contractor the cost. Now, this is a figure or a depiction that I could discuss with people who are interested personally, because it needs to get into, one needs to get into details to actually work out as to how we work out what is payable to the contractor. But the crux being that overall TRC was calculated for extensions on critical path and paid as per the actual pace of ground. This helped us, only during the contractually extended period TRC was paid to him. It was paid as per the progress of the works, and when he completed the work, all TRC was paid. The increased pace of work helped him earn the balance TRC, because it was then attached to the work that he was doing on ground. And with each payment, we did that. I'll take a minute extra. I'll request the convener. My time's up. I'll just take a minute extra. Yeah. So what's the way forward? The way forward as to what we have learned from probably Atal Tunnel, from Sela, from Nechipu, and running these various contracts is that first we need to concentrate on basic rock mechanics, the excavation, the support sequence, the opening size, doing pre-excavation supports, and understanding what is sequential excavation method, so that we can deal with EGOs or poor ground or squeezing ground when we come to them. And all this needs to be built into the tender somehow. Investigation and exploration is very, very important. We have to prepare our DPRs, which ensure that we get the right, we have the right inputs for somebody to take on the execution of the projects. Characterization, we have to, probably discontinue using empirical methods till we evolve our own, or, we should start working on that data and do more geomechanical modeling and divide the ground more into behavior and ground type, which is increasingly happening now in most projects. Observation is important. We have to monitor and optimize if we have to optimize the cost of construction. We need to understand the advance rates, sharing risks, geotechnical baselines is something all of us need to understand today. The requirement of tech expertise and contractual flexibility remains. It's a good thing that the Ministry of Road Transport has gone ahead with a body of experts, and they can be referred to if there are issues. Then there are dispute redressal mechanisms and expert agencies, which are now in play already. Geological data sharing. Probably what we are not doing is the railways and the roads and various organizations. We do not share data with each other. Our geological face logs should be available online.
Please conclude.
Yes. And so I'll just come to the last 2 points. I think the other thing that we can do is what we can take away after this conference is to have a tunnel data book which has a basis of advance rates, and probably we can run nationwide investigation campaigns. In one of the presentations we saw yesterday that investigations happen 10 years before the project actually gets into the contract phase. So probably these are the kind of things that we can get into, and it'll help us. Finally, this was Atal Tunnel. We were fortunate we had the Honorable Prime Minister come to us. Thank you.
Thank you very much. Thank you very much, Mehra, for a very nice presentation on challenges and risk management, citing a live example of Atal Tunnel. Now we move on to the last presentation of the session, that is on risk management plan for underground road tunnel, and this will be done by Mr. A.K. Srivastava, ADG retired Moth. Mr. Srivastava.
Thank you, Chairman and Co-Chairman, and ladies and gentlemen. I remember those days when India was having a challenge to go for 4-laning of Golden Quadrilateral. That was a big challenge around 90s and 2000. Don't you think that we were having challenges and risks? Yes, we were having, and we resolved. Then subsequently we took the challenge for the East-West corridor. There was many challenges and risks. That was taken up and we succeeded. Similarly, the phase for the bridges came. These days, we are making 8-lane bridges on single pier. And extra dose bridges, perhaps India is the country where the maximum extra doses bridges in the world are being made right now. Therefore, we are having challenges and risks, and we are trying to resolve it. And similarly, the next phase is coming for the tunnels, for which I think we should make ourselves ready to face the challenges and resolve the risk. And perhaps I am confident that our children used to complain that parents, you are not fair, yes. But they understand the limitation and they used to stop the complaint that parents are fair. Therefore, this is the motto that we are doing, and we are succeeding. With these words, I would like to share my views on these issues. Plan. Just for introduction, I think it is already discussed a lot that India is a country with a vast and varied geography, with Himalayan range as one of the massive ranges in the world. Hence, constructing highway and highway projects in this region, tunneling plays a vital role. Tunnels are required for connecting remote locations, making all-weather connectivity in mountains in terms of both socio-economic and strategic regions. Some highway tunnels, this is just an example which I shared, that how we have crossed these road networks and bridges, and now we are going to take the challenge of tunnels. That this, I have given you a small example that J&K is a state of India which constitutes only 3.5% area of the country. And now see the clustering of the tunnels, how we are having the challenges for the connecting this. The Srinagar, Leh and Ladakh region, all of us know, and foreign delegates also may be knowing, because a lot of discussions have been done on this issue, that it remains cut off about 4 to 5 or 6 months due to the snowfall and all. Therefore, we are making 3 axes for the all-weather connectivity and the rest of the world and throughout the year. And see the location of tunnels which we are making. And there are 3 axes on which, if we will be able to make these tunnels, we will be able to make it all-weather connectivity. Then these are the list of tunnels. Like Chennai Nasi, Kwajigund, Jedmore, Jojila, Rohtang, Baralacha, Lachungla. Some are already ready, some are in progress, some are in planning stage. Tanglangla and Sadhna, Khardungla Pass and Chadargala, and so many tunnels that I have listed, about 19. There are many, but these are the small examples that I can share with you. Now, major challenges and risks associated with tunneling in India: varied rock strata and heavy overburden, underground aquifers, occurrence of natural calamities, heavy rains and landslides and avalanches, snowfall during construction period, geotechnical investigation more difficult in mountainous terrain, remote and harsh locations, pose logistic problems, investigation and construction. What is the result, sir? Source of several uncertainties. Hence, variation in the cost and time becomes unavoidable, and geotechnical design is made under condition of uncertainty, which we are discussing since yesterday. Socio-political financial challenges. Now see, what is the demand and what is the desire of different sections of our society. Political masters and public. What they want? They want no patience to wait for a long time to see the implementation. They want immediate result, immediate outcome. Financial pressures. Desire task, fast-track solutions with quick and sure economic returns of investment, because lenders are also demanding this issue. All demand for certainty of the project, cost as well as duration. Now see, uncertainty at one end, certainty at other end. There is a tug of war between these two. Now we have to plan how to minimize it. I am sure that risk and uncertainty we cannot eliminate, sir. This is my view, but we can minimize, which we will show also that how to approach this. A risk and risk. What is risk? My dear sir, this is a probability of something negative happening caused by an event or activity. The combination of failure and the probability of failure. Now, what is the management? to accept risks that are reasonably small. Yes, that is acceptable, which cannot be avoided due to certain extraordinary expenditures and all that, but reasonably it can be accepted. And define appropriate measures for the risk which are unwanted and unacceptable. A risk management plan. This should be developed, and perhaps this should be made part of the contract document after getting the legal vetting and all. But this approach we should keep in mind. But for long run, which it will be very helpful for the tunnel projects and underground structures. RMP methodology to be adopted from planning, design stage to the construction and operation. This is not applicable at only at a particular stage, but this is a continuous. To minimize the occurrence of risk and mitigate their consequences, RMP elements for tunneling projects involve risk identification, risk evaluation, and risk mitigation, residual risk assessment, pre-design of countermeasures for the management of residual risk, especially during construction. The risk remaining after the implementation of the rectification measures is called residual risk. Suppose this is measure 1 and we have applied all the resources, design and all that methodology, and after that it is something remaining, that is called residual. Hazard and risk identification. How to identify? Because this is our plan to identify. Define project objectives, requirements, establish the tolerance of the owner to the risk, both for the uncertainty and for the level of risk assumptions, characterization of project, reference scenario, and identification of hazards and risks through a complete list of potential hazards and related initial risks. Now see how risks are generally classified. There are different sections where these risks are involved. For example, design related risk. Design errors and omissions. Design process takes longer than anticipated. Stakeholders request late changes. Failure to carry out the works based on the contract. Similarly, construction related works. This involves a big list perhaps. There are some important here. Cabins or excavation collapses, construction equipment of failures, falling of excavated materials, changing conditions, strata and stress field fluctuations, and tunnel instability, high noise levels and vibration and dust during excavation, excessive seepage and groundwater inflow, fire and explosion problem. Similarly, project management related. Failure to comply with contractual quality requirements, contractor delays and scheduling errors and project term conflicts, environment related risk, environment analysis incomplete, air contamination or oxygen depletion, incomplete environmental analysis, and improper and delay in resettlement of the landowners. This is a right of way and conflict with the landowners. Risk classification, organization related, inexperienced workforce and staff turnover. This is very vital for underground construction. Lack of production on a construction site, new stakeholders for external these factors risk. Risk evaluation quantification. For each identified hazard, the potential causes are specified and risk is evaluated through an assessment of its probability of occurrence and its impact on the project. The preliminary estimate of the project vulnerability to different type of risk is achieved if qualitative quantification methods are used. Risk assessment results should be reviewed in consideration with the possibilities for risk retention, risk reduction, and risk transfer and risk avoidance. qualitative risk analysis. This aims at identifying the hazards threatening the project to evaluate the consequent risk to determine the strategy for risk treatment. This serves as a basis for preparation of contracts, for management of the project, and for allocation of responsibilities amongst the stakeholders and their employees and representatives. Similarly, quantitative risk analysis. This is more important than the previous one. Qualitative aims to numerically evaluate the risk very precisely. Compared to the QLR, requires a clearer structurization of the problems, related analysis of causes and consequences. And in this regard, there are some methods and models are available which will help it out to how to address this issue. Fault tree analysis, event tree analysis, Bernoulli process, binomial distribution, Parsons process, and other methods. Risk mitigation. See, risk mitigation, once we identify all risks, should be reduced to level as low as reasonable and practical. That is called concept alarm. This involves weighing a risk against the trouble, time and money needed to control it, definitely. Then this is the inverted pyramid. Once you see that categorize one, the top one, where is unavoidable. We should not leave it unavoidable. That it is not acceptable. Tolerable. Then the next zone is tolerable. Yes, it can be considered and handled. And acceptable, that is the third level. If a risk is unavoidable, it has to be mitigated by identifying a list of response actions, design approach, construction technique, installation methods to reduce the initial risk. After implementation of mitigation measures, the risk has to be re-evaluated in order to quantify the residual risk. Residual risk assessment, risk response monitoring. This is the method that we should find out the risk, residual risk assessment, and monitor that. I will show you that flow chart. By that, it will be very easy to understand. See, there is a risk matrix, and which is quantified by risk value, which is probability into impact. Now, this is the matrix graph. You can see that x-axis is probability of occurrence is there, and impact value is on the y-axis. Therefore, categorize and identify and accordingly find out the location. And if it is a red portion, then this is to be reduced. And we should bring from the right hand side diagram that we should bring to the residual risk, applying all resources of design, finances, this management and everything. Now, this is the qualitative risk analysis case study, which I have discussed just now, that like C, construction related risk, and D means design related risk, and like this. Therefore, this is the case study from the this has been written in the University of Addis Ababa Institute of Technology, and this has been beautifully captured. That you see that if you will have a look at C1, construction related issue, then see this impact. How this impact is the maximum 1, 2, 3, 4, 5, and its likelihood is very less. And C1 is what? Design errors and emissions. If there is a fault in design, then see how it is impacting this up to the maximum level. Similarly, this come to D1. D1 you see, D1 is also D1 is design errors and omission, and C is the cabins and excavation collapses, because that is due to so many reasons, that design fault and all that excavation method. And similarly, O3 you see that how impact it is. O3 is a lack of protection on the construction site. Therefore, from this case study, it is clear that how meticulously we should examine the risk related issues very precisely. This is the matrix that risk very high if it is coming, then in a top red corner, then bottom red corner, it should be risk reduction is possible. And third zone is a risk transfer, which is coming in third zone, and low risk, it is acceptable. Now this is the this matrix plan, which whatever we have discussed, this logical sequence of risk management plan steps is there, because it is very helpful to how to go and how to design it. That is step 1, critical design of analysis, design elements. Step 2, preparation of the reference and design scenario. If it is okay, go down. Selection of the construction method, which we have discussed yesterday also in details. If it is okay, go down. Identification of sources of hazards, go down. And identification of a specific hazard and relevant causes by complying in a risk register, because you should maintain it. And again, it's okay, go down. Assessment of each single risk by assigning an impact and likelihood of occurrence to each hazard, which we have did just now. Similarly, 7th step, initial risk acceptable. If it is yes, okay. If it is no, then you should go back to a step 6, mitigation measures with mitigation measures, and again come down. Similarly, if it is yes, go down, updated design option into the most safe reference design scenario. And if it is okay, go down, residual risk acceptable. If it is acceptable, yes, go down. If it is no, then go back again to a step 4 and step 7, and again come back and reallocate the resources and try to reduce it. And if it is okay, then go, declaration of time and cost of the project, strategies for monitoring of limit residual risk during construction. If it is okay, then a start of construction. And then if it is all right, then residual risk within acceptable limit. If it is no, then go back again and then on new identified risk, because it is not like this that once you have identified any risk, it is okay, but it can be still there. If it is yes, again go to the step 7 and step 4 and come back again. And if it is yes, if it is no, then yes, activate predetermined countermeasures. And then it comes a residual risk within acceptable limit.
Please
yes.
sum up.
Sorry, 1 minute. I'm going to close it. End of construction and review and countermeasures we should take care of, and we should move. Advantage of RMP assures the timely identification, resolution of potential problems to reduce to a level as low as possible all the risk identified in each stage of the project life, and to implement the preventive measures. Essential features of RMP, which we have already discussed there. Conclusion. From the viewpoint of risk assessment, tunnel design and risk assessments are mutually dependent on each other and go hand in hand. Useful risk assessment may be obtained only through a correct understanding of the design and construction process involved. This may be achieved by a multidisciplinary team of experts. A sound and robust design of a tunnel can be achieved only if it is developed on the basis of a comprehensive risk assessment. From the viewpoint of risk management, in the design stage, analysis of initial risk should guide the development of the tunnel design, and correct choice of the execution method should be ensured for a given tunnel project, being the first risk mitigation measures. With these words, thank you for presence hearing. Thank you very much. Thank you.
Thank you very much, Mr. Srivastava, for a very exhaustive and enlightening presentation on risk assessment and risk management. Now the floor is open to the questions and discussions. Before asking the questions, please identify yourself and identify the speaker so that your query can be answered appropriately. Please reach the mic.
Good afternoon. I'm Colonel Sudhir. I'm the Executive Director, NHIDCL Jammu and Uttarakhand, handling about 5 road projects, out of which one has gone into arbitration, still working. So my question to Professor Arnal would be, the biggest risk which we find today is the surprise geological conditions once we start the excavation and what we plan for. And our IRC SP 91 says about 3 to 5 boreholes for a 4.5 kilometers tunnel. It's certainly insufficient and loading the risk onto the contractor. So we have, so the biggest point now is to investigation, soil investigation, pre-construction activities. And the aerial electromagnetic survey, we've tried it once at Zojila. Though it's not very well followed out here and it's not been covered by anybody till now, I would like to know that the efficacies of it and is it been why it's not been propagated, because as per me, it's one of the better, that's one as near as what we can get to almost about 900 meters. The second question to Colonel Parikshit is the Atal. Okay, can I?
So on the first question, there's a sub-question, and that is, do I throw you your chocolate? Shall I? Oh, there's a catch. Okay, so we're good. You see, the Olympics are coming. You feel that spirit already. So now, I'm assuming your jumbo is your business. You've invested an enormous amount in your jumbo machine. It's your jumbo, your company jumbo machine. Okay. I don't mind if the ground conditions you experience aren't what you were told they were going to be, so long as there's a fair way to pay you to do the job that you now have to do. Because sometimes a government or a client has to move quickly for a whole range of reasons we can't see. All I ask is that there's a mechanism in place so that the payment to you is of value. Right? That's what I. So so you can have a contract like that, and it can have the ground reference conditions, and it can have everything like that, but so long as it's fair. So that I can answer that bit. As for the other technology, I don't know. I haven't worked with that technology. Perhaps somebody else has here.
So thank you. Basically, now when we have a contracts also, the FIDIC has made all kind of contracts even for the World Bank and things like that.
Yeah.
A special tunneling FIDIC contract is probably the need of the hour. What you're trying to say is, I'm from the authority side of it.
Yep.
I'm not the contractor. I have not invested any money, or it's not my jumbo.
Yep.
It's just my concern because I am bothered for my work.
Yep.
And this basically leads to certain litigations, slow in the payments. The
Yep.
contract conditions are not such that even if you want to do the payment for unfavorable geology, today it's not existing. So we, like you're in a EPICS body which is interacting with FIDIC. FIDIC, you can, I would say FIDIC is an organization when you demand, like World Bank demanded that they wanted a pink book was made for them. It could be a grey book or some other book for the tunnels specific coming up.
Yeah. So the FIDIC book is also an ITA book. So this is the only FIDIC publication. This is the Emerald or Green book. It's the only joint FIDIC ITA book they've ever produced. Always it's a FIDIC. This is the first time they have an industry-specific underground contract. They've never done before. They did one for dredging, but they still call it itself dredging doesn't really count anyway, because we're tunnellers, right? So we can have provisions and there's a model for provisions which would allow you as a client to pay a fair price for the works that have to be done. But you would want to have experts on your team that can deal with experts on the jumbo contractor team to decide on what form of support has to be done, and in advance have to agreed on a price. So the dispute is not about, oh, we have to change the mode of support, the ground's not performing the same. No, the only question is, do we agree this is the ground support we need to provide, and we already know what it's going to cost?
Thank you, Vinay. Thank you. Next question, please.
Hello, I am Rajesh Kumar from Ministry of Road Transport and Highways. I have a question. This tunnel contract should be on item rate basis or on EPC basis? What should be the preferred mode? And what is the most desirable to have less disputes?
Who you want to answer?
Mr. Arnold Dix.
Oh, you want a chocolate? Okay, here we go.
Risk very ill calculated.
Okay, I'm going to prison now. I'm very sorry. Oh dear. Yeah. I'll try. No. I think I'll quit while I'm ahead. Yeah. So what? Sorry. Tell me the options.
One is item.
Item rate contract or the percentage rate?
So I don't want either.
Hello?
No, I don't know the.
Honor.
Yeah. So your schedule of rates or fixed cost. So the one I definitely don't want is fixed cost, because how can we have fixed costs? Because we don't know what we got to do. And the item of rates one, I also am nervous about, because you can end up using too much. So that is why I prefer a contract which divides it into classes of support, and we agree on what we will pay for the classes of support, so that it's neither type of contract, it's a different style. This is my experience. Okay. Like a hybrid sort of contract. Now, does that mean you want a chocolate over there? Because that was okay. I'm worried about injuries now. This is.
I'd like to supplement it that EPC contract document, which is silver book, where this is specifically mentioned that EPC contract doesn't recommend fully for the underground constructions. There are certain limitations. Therefore, definitely EPC may not be as good as the FIDIC concept. But issue is this: how to accelerate the construction pace and how to bring the cost and time over an issue. Therefore, a hybrid mode. Emerald book color also has been developed by World Bank. And therefore, a time has come that we should look into this aspect and we should develop a acceptable type of contract document exclusively for underground tunnel constructions. Thank you.
Okay, thank you. So I think we will take the last question.
Yeah.
Okay.
I have one question for Professor Arnold. I am Sumit Jain from RVNL, and Emerald book came out in 2019, as I remember, and it has been recently endorsed by World Bank also, very recently. But since 2019, how many projects have actually implemented this book, and do you have any feedback on the experience of implementation of this book? And when do you think World Bank will be pushing this book as a requirement over the World Bank projects?
World Banks have started with it on a couple of projects, and we know that our projects take decades, usually, at least 10 years. We have preliminary feedback that so far it's okay, but there will need to be some adjustments. There's some provisions that they'd like to change. We don't really have enough data yet to say how well it's working. What we do have a lot of data on is other projects which aren't FIDIC contracts which have used these types of arrangements for risk apportionment seem to work a lot better. And the other data that we have is special contracts for the special circumstances of, say, a region with a particular, I'll call it way of dancing, a way of doing business, seem to work very well too. So a Swiss contract in Switzerland works really well. It might be that you could develop an northern Indian Himalayan contract for northern India, Himalaya, which takes the essence of this risk apportionment in this type of geologic and social and economic context into consideration. This is a very advanced step, but given what you have to do, I wouldn't rule it out.
Thank you.
Should I supplement your queries? That in fact, you know that World Bank says to use FIDIC and our Red Book, Orange Book, etc., then Emerald Book also. But World Bank doesn't restrict that Emerald Book in toto it should be used. It is up to us. Make it the SCOPA, condition of particular application. And wherever you feel that yes, certain clauses are to be deleted, try to bring it, try to be modified for mobilization advance, free and all that. There are so many issues are there. Therefore, it is our baby to control it.
Okay, so I think we are going to take the last question from him. Please give mic to him.
But his toffee is due, Mr. Dix. Mr. Dix.
Your toffee is due to him.
Chocolate is due. Why
Yeah, I was worried about injuries.
Yeah.
I already have one court case here in the front against me.
Please go ahead. Yes.
I'm worried I won't get out of the
So that's
country.
going to be the last question. Yes.
Myself, Puran Singh, Superintendent Engineer, Ministry Road Transport Highway, working in Dehradun Regional Office. I have just like previous day investigations to reduce the project risk if you contribute time in investigation and DPR. So as to reduce the contract complexity and claims, how we improve the DPR contract in their times. At presently, we are giving only 10 to 12 months for DPR preparation. Is it sufficient or it is required further time linger on? Second question regard bidding process. For the contractor is given only 45 days. He has not sufficient time to investigate and evaluate the contract. So these two issues, the experience of Mehra sir, how this contribute to increase the complexity, how to improve these issues, sir?
Thank you, sir. Thank you for the question. Exactly my point, what I was trying to bring out is, we have to do these DPRs in advance. Why can't we disassociate this process of doing our DPRs from the execution? What happens with us is we conceive a project and then we start doing the DPRs. Why can't we have a long-term perspective plan of developing an area, doing the DPRs well in advance, so that we get time for exploration and investigation, and so that when we go in for tendering, we have a good solid DPR with good ground data, and then do it. Only then will we be able to make a good contract, because we will be able to give the contractor good data in the DPR. So we all know, we are all executives, we are under pressure that we have to get this project going, and we end up giving the DPR contractor probably 6 months. For an investigation, that should take him probably 3 seasons in high altitude, because he would not be able to access the sites, there would be snow, there would be issues that, he has to mobilize equipment from far away, especially for tunneling sites. And we end up telling him that in 5 months I want this DPR. What does he do? Then he does a geophysical survey and he gives it to you. He doesn't do any intrusive surveys. He cannot carry the borehole investigation equipment there. So the best thing is we have to make perspective plan for our states, for our areas. We have to do the DPRs well in advance. I also gave out one more point in my presentation. I was slightly rushed in the end because I probably took too long. Is that we should do national investigation programs. Why can't we do boreholes everywhere in the areas where we are going to develop, whether it is road, rail, or any other mode of underground works? Why can't we run national campaigns which are independent, and that data can be picked up by our DPRs? That will be the way to go ahead. We'll get a lot of good, rich data. We will be able to do better research. Our students will do better, and we will get better DPRs in the end to execute projects on. So I think that's the way it's.
So thank you very much, and it has been a very vibrant session, I think, and it has generated a lot of interest, which will go further ahead. Now, to sum up from our side, I would like to invite my co-chair, Mr. George, to give his comments on the.
Thank you. Yeah, I'll try and keep this fairly brief. I know we're in a rush. Firstly, presentation by Professor Arnold Dix. He spoke about the fairness of contractual requirements. He gave us different perspectives of the contractor and the client. And he also looked at the perspectives of other parties, the local communities, the politicians, about the outcomes of project, which I think is a very important point. He went looking for what is best practice contracting, and he found the FIDIC book, and he presented it as a good guide for good contracting. He mentioned the importance of stating what the priority is of each of the relevant contract documents. The contract document refers to the engineers, not the lawyers. A really important point, I think, that he made, that give the engineers the opportunity to sort out any differences before you refer on a problem to the lawyers. We all know that if you refer a problem to the lawyers, the problem gets bigger and it costs you a lot more money. Absolutely agree with Arnold. There is no such thing as a perfect contract document. We now insist in Australia on what we call a collaborative contract management approach. So your contract's your contract, but it's the way you engage with that contract and that you work with it and your partners to work things out together collaboratively. So you'll see this a lot in contract terms in Australia. All the parties to a contract work really hard to avoid contract disputes. Planning for contract and project success is crucial. You need to work out what arrangements will best suit you and your contract parties that will lead to collaborative working arrangements. Our major projects cost a lot of money, we all know that, and we can't afford to divert precious limited budgets into pockets of lawyers and into the legal processes. Really enjoyed Arnold's interactions with the audience. Well done, Arnold, and I'm very pleased that you didn't throw chocolates during your presentation. The next presentation on challenges and risk management by Parikshit Mehta. At a high level, he emphasised the importance of giving thorough risk assessment early in the planning phase of major projects and in relation to shallow tunnels and deep tunnels. Projects which give lots of time to risk analysis in the planning phase typically are more successful than those projects where inadequate risk analysis is undertaken. I've seen major projects dedicate 1 to 2 years or even more to properly plan and risk analyse their projects, and typically these are the projects that finish on time, within budget and to the quality requirements. Parikshit based his presentation on the Atal Tunnel and the particular aspects of that very interesting project, particularly traversing a major fault line. A very challenging environment to design and construct a tunnel, as pointed out to us by Parikshit. For me, the presentation shows us how extensive geotechnical investigations very early in the planning phase is crucial for deciding the most appropriate alignment of tunnels, both vertically and horizontally. A very interesting presentation that he provided us with some key messages about risk management and contract management. Thank you, Parikshit. The final presentation on risk management plan for underpass road tunnels by Mr. Shrivastava. He spoke about the significant challenges in managing risks associated with major infrastructure and reliance on tunnel construction in the region, and the potential impact on time and cost. Demand for certainty. While this demand is understandable, it can be a factor to project failure from experience. I don't know if you're aware of this, but for the new Elizabeth railway line in London, it's an underground railway line, the politicians wanted the project time to be fixed and certain. And so everyone worked to the fixed time that was set. And for 4 years or 5 years, they reported to be finishing to that fixed time. But suddenly, the project team became bold and announced that they would be running late and over budget. And from that point on, they became very realistic about their programming in time and cost. And that was the best thing for the project. And yes, it did go 2 years over time and many billions of dollars over the original budget, but at least it was honest and they worked to realistic programming thereafter. Mr. Shrivastava presented the various risks risk categories, assessments and mitigations. He gave us an outline of qualitative and quantitative risk analysis processes, both very important in the planning and delivery of projects. Another very interesting presentation on the fundamentals of risk management. Thank you, Mr. Shrivastava.
Thank you very much, Mr. George, for very well summarizing all three presentations in a very candid manner. And at the end, I would like to add only very few things from the perspective of a field engineer. At the very beginning of the presentation, Professor Arnold talked about the fair contract. Why the contract has to be fair? Because when the contract is fair, then it is a win-win situation for both the client and the authority. And if it is not fair, then it is the win-win situation for the people waiting outside the room. And they are the lawyers and arbitrators. So better to make a fair contract so that it is a win-win situation for the client and the authority. Second thing is that regarding the risk management, I would like to say the very well-known saying that it's always better to sweat in peace than bleed in the war. If we sweat more in the peace, then we bleed less in the war. So the risk management and risk analysis is something like that. That if we do a proper risk analysis and risk assessment, then definitely the project is going to be executed in a very smooth manner. Otherwise, definitely it is going to be held up somewhere, and then a lot of problems arise, and the project gets delayed, time overrun, cost overrun is there, and as I told, that then it becomes an advantageous situation for the lawyers and the arbitrators only. So the risk assessment and risk management are very important part of any project. And as I was waiting, that Mr. Nirmal has just joined us, the IRC General Secretary. So my last submission is to him that I would like to request our IRC fraternity through him that we have already traveled a long route in our country of the mega projects. Some 20 years have gone since when we are executing the mega projects on highways and underground works both. Now this is the high time to review our contract documents. Though we have done so many revisions and so much work has been done since then till now on the contract documents and contract formulations, but still a lot more is to be done. So because I feel that as field engineer, we always find dearth of the available knowledge regarding the contract management and contract handling. So it is the high time to come up with a comprehensive document on different type of contracting systems on highway projects. And if IRC takes up this challenge and initiative, then it would be very good for the field engineers. And it should be written in a very lucid and very comprehensive, understandable language so that it can be easily understood by the engineers and it can be easily interpreted by the engineers. Because most of the contract documents, I find that it is very difficult to draw inferences what a particular clause is saying. And then it becomes very difficult to resolve the dispute at the very beginning. So it will be good if we come out with a revised contract documents from the field engineers point of view. And there is a need of commentaries also, which may explain the clause by clause provisions of the contract documents. As we have commentaries on the FIDIC documents, so we should have the commentaries on our IRC contract documents. So if this work can be taken up by IRC, I think that will be a great service to the field engineers. Thank you.
Okay, well, I think we're done. Yeah. Oh, no.
Thank you so much, gentlemen, for the fantastic presentation. Now I'd humbly request Mr. O.P. Shrivastava, Chief Engineer, Ministry of Road Transportation and Highways, to kindly come up on the stage and extend the felicitation to the distinguished guests at the high table. Professor Arnoldis, President ITA. Colonel Parikshit Mehra, Indian Army. Mr. A.K. Srivastava, former ADG Mort and convener H10 IRC. And finally, the chair, Shri Arvind Kumar Jain, Vice President IRC. And the co-chair, Mr. George Mavroini, Pi Arc. Thank you so much, sir. Those who wish to visit the technical site to the Rishikesh and Karnprayag tunnel project are kindly requested to register their names by 12 noon today at the registration counter on the ground floor and fill the consent form. And there will be a parallel session in the Vishwasarya building on the case studies of road tunnel project, part 1. With this, I declare this session for a hiatus and request everyone to enjoy the high tea with us at the Vedanta reception hall. We shall continue with the scope of the seminar in the auditorium. Thank you so much. The commencement of the next session will be at 12:20. Thank you. Co-chair to proceed towards the high table, please. I would now request Mr. D.K. Sharma, Chief Engineer, Ministry of Road Transport and Highways, to kindly come up on the stage and felicitate the chair and the co-chair. Thank you so much, sir. I take this moment to direct the audience present over here towards the direction of a seminar that will be held. First, we will go through the presentation on the execution of India's largest TBM tunnel project in the urban environment of Municipal Corporation of Greater Mumbai, Mumbai Coastal Road Project by Mr. Sandeep Singh and Mr. Sanjay Pajni, L&T India. Moving from that, then we shall be understanding the National Highway Authority of India tunnel experiences overcoming extremely challenging geological conditions in Ramban, Bani Hill, Jammu and Kashmir, and Pando Takoli, Himachal Pradesh by Mr. Amrendra Kumar, CGM NHAI. And to conclude this session, we have the presentation on 57 kilometers railway tunnel between Lyon and Turin under the Alps by Lucy Roux, United Kingdom. I request all the presenters to kindly proceed towards the high table. With this, I request the respected committee to now take over the proceedings of the session. Thank you so much.
Good afternoon, ladies and gentlemen. So first, I welcome my co-chair and all the three presenters to the dais for taking this seminar forward. In fact, we had planned total 12 technical sessions in these two-day seminar, out of which 8 sessions were devoted to all the design issues and all technical issues related to tunnels, their complications. And the 4 total sessions, 2 sessions today and 2 sessions, in this hall and 2 sessions in the other hall. So now, starting from this session, these 4 sessions have been totally dedicated to case studies, because that is a very important part of any seminar or any workshop. That what is the learning? We have done so many, because that is what is very important, that if you do some mistakes and if you learn from the mistakes and we improve the mistakes for the future projects, so that is what is very important. And that is why in this important component, and we have kept in mind that we should have the international experience and see what we can take away from this particular session, where we will discuss about the various topics. In fact, in India, as we have already heard from our secretary also, that 2.7 lakh kilometer, that is 35 billion Indian rupees, US dollar, 35 billion US dollar is to be spent in 1 year by Government of India on national highways alone. And we have a very important projects in our northern parts and northeastern parts. We have Arunachal package, Trans-Arunachal Highway, that is also entirely hilly and mountainous terrain. Similarly, in the northern part of India, from Jammu and Kashmir and Himachal and these Uttarakhand, all these northern states, there also we have a hilly terrain. So when we are constructing our highways in hilly terrain, then there are a lot of challenges. Particularly many areas are snowbound. So keeping the traffic open throughout the year is a very big challenge, because whenever there is a snow and heavy snow, we cannot have traffic, and many of these roads were closed for even 6 months or even longer, or even now it is closed if there are no such provisions that there are tunnels or this kind of structure. Otherwise they have to maintenance also is a very tough task in snowbound areas. Similarly in Arunachal also we find that there are mountains and hilly terrain, and there also we have to take circuitous route and very longer routes. So there, if we plan some tunnels, then we can shorten the distances by as much as 90%. We can reduce the length of road projects if you construct tunnels. In fact, last week itself there was a debate in our government, highest level, in the level of Prime Minister office, that can we avoid the construction of tunnels, because they are very expensive and they are creating some issues related to environment, particularly in this state, Uttarakhand itself, there were environment issues. When we were discussing about Char Dham Pariyojana, then widening of the road, whether we should have a paved shoulder, because normally 2-lane highway is a 7-meter width. But National Highway proper standard, if we say and no National Highway double-lane standard, then that means 2-lane plus paved shoulder. So there was a huge debate that is it required in hilly terrain to have this extra widening of paved shoulder. So this issue was, even it went to court, Supreme Court, they appointed a committee, and then it was debated whether that much of widening is required. So because ecology is getting disturbed. So ecology, and yesterday we heard our PWD minister also saying that you have to construct eco-friendly tunnels. Tunnel is a very important element if you want to avoid this cutting of trees, because that also is a very sensitive area. So, and particularly there are very big challenges when you are constructing tunnels in urban areas. In fact, when in 90s we were planning to have Delhi metro, then a lot of discussions were taking place whether it is possible to have a metro inside a city like Delhi, where there is hardly any ROW available in the entire, it is a very congested area, it is highly polluted area. How we will construct our tunnels in Delhi? In fact, it was, I also happened to be, that time I was in Netherlands and discussing, doing my MTech. So there, in our transportation experts, I used to discuss that what is the option available to India when we are constructing, we want to have metro in Delhi, so that there, all the experts were unanimous that in congestion area, there is no other way. World over, whatever is the practice, that they have to go for tunnels wherever there is a congestion. And that is what we have seen, the success of Delhi tunnels, the Delhi metro tunnels. And all the metro cities, I think tunnels are coming in a big way. So this particular session, we will be discussing about the 4 important case studies, and they are dealing with the different aspects. So one of the case study, the first case study is talking about the largest TBM tunnel project in urban environment for Municipal Corporation of Greater Mumbai. That is a project which is already ongoing. And it's a big challenge because they are talking about undersea tunnels and in urban environment. So this is, I think this is a very good presentation. And then there is a presentation about NHAI tunnel experience, because NHAI has constructed large number of tunnels, and especially the tunnels in Jammu Srinagar connecting, because Jammu Srinagar is a very important national highway in India, because to give the connectivity to Srinagar, this is a very important national highway, and there are large number of landslides, slow failures, and big challenges regarding geology of those hills. Even during construction, last year when they were constructing tunnel, there was a casualty during construction itself, and there were some deaths also in that construction. So there are big challenges in not only in northern part but other parts also. So in this presentation we will be discussing about what challenges they have faced and how they have tackled these challenges. And then the last presentation is talking about the 57-kilometer long railway tunnel connecting France and Italy by Miss Lucy. So these are three different environments, talking about the urban environment, talking about the national highway, talking about the railway. So I think this will be very, very interesting session, and we will see the takeaway, because at present in India, IRC is having a committee which is talking about hill roads as well as tunnel combined. So there is one single committee. So they are focusing more on hill roads, and less time was given because already IRC 91 has been revised in 2019. We have received many feedback about modification of the IRC 91, but I was holding this feedback because I wanted to get this particular international seminar. What is the takeaway of this seminar and what improvement should be done in the IRC code? And I think in the last session today we will try to discuss that where we can improve the existing IRC code and what many more codes are needed to address these issues of all tunnel construction, because they are coming in a big way. More than about 200 kilometer length of tunnel DPRs are in progress in India at present. So they will be taken up in coming this year and coming 5 years. So we have to update our existing code as well as to prepare new codes in new areas. So that takeaway also will be very important for us. So now I will invite the first presentation on execution of India's largest TBM tunnel, and this will be presented by Mr. Sandeep Singh and Mr. Sanjay Pazni from L&T India. So please, you are given 20 minutes. Okay, thank you.
Thank you. Good afternoon all. I hope I'm audible well. Okay, so this is, I'm going to talk about this Mumbai Coastal Road project today. And this is in the middle of the Mumbai, South Mumbai, connecting Bandra-Worli Sea Link. I'm sure many of you might have traveled on that sea link towards the South Mumbai. So it has got a lot of benefits. We'll talk about it as we go ahead. Yeah. So the flow presentation would be like that. I'll just come down so that I can watch it. Yeah, the flow of presentation would be like it is the details of the tunnel and the geological conditions, what we are going to get, what are the hindrances, how did we recover the timeline, and what are the auxiliary equipments to improve the productivity, and other challenges. So basically a case-based presentation. So talking about this project totality, it has got 3 packages, package 2, package 1 and package 4. This package 2 is where the Bandra-Worli Sea Link stops, and from where the extension is happening towards the south. And this is the portion where the Bandra-Worli Sea Link is there, and it extends up to the south portion. And then there is a package 1, and then there is a package 4. So we'll be focusing on this package 4, which is completely underground, comprising of bore tunnels and cut and cover and ramp and at-grade structures. So some of the highlights of Coastal Road. It's India's largest diameter tunnel as the topic. It's a 12.19 meter diameter tunnel boring machine being used here. And a lot of first times are there in this project, such as the Sacardo ventilation, which is so far we have jet fans in all other tunnels, but in this case we are going to use this Sacardo fans. And monopile, because this is also comprising of tunnel as well as bridges. So we have got monopiles. Instead of group of piles, we are going to use monopiles. And that is for the first time. So this is the dia of up to 2.2 to 3.2 meter diameter of single tunnels, single piles. And yeah, there is a benefit of a lot of time is getting saved. What used to take 1 hour 20 minutes, going to be 12 to 15 minutes is the promise of this project. And then there is a lot of green area being created out of this reclamation. So it's around 70 hectare areas for kids play and amusement, for recreation purposes. And of course it is creating a lot of direct and indirect employment also. It's approximately more than 6,000 workmen as of now, as we speak, in the 3 packages taken together, and some indirect benefits from many other suppliers and supply chain. So focusing right now only on the package 4, this you can see this is the portion called, it's a Priyadarshini Park area. This is the Priyadarshini Park. Here is Malabar Hills. Thank you. This is Malabar Hills, and where our TBM has to get overburden of 68 meter. And this is all Priyadarshini Park area, which we have reclaimed it. This reclamation was done from the intertidal zone. So the sea used to come over here in this zone, but we have reclaimed this land for the purpose of this road alignment. And then the launching shaft you can see, and this is the twin tunnel, tube tunnels, retrieval shaft here again, and then the rest of the cut and cover and ramp and at grade structure. Some dimensions you can see. So this TBM has got name Mavla, and this signifies the Maratha warriors, and on that name it has got this name. And this is considered to be India's first undersea tunneling. It is passing very near to the sea, and at one place it is going below a portion of lagoon or creek, we can say. And it passes through the this Malabar Hills, where the overburden is as high as 68 meter, whereas in the beginning it is as low as 4 meter only at the start point. Then we have this lot of heritage building, it's going below, so it has its own challenges of how do we ensure our mining parameters and all. We'll be talking about that also. And then there is a state-of-art SCADA, this SCADA system, which is to monitor the traffic flow, traffic control management system. So all very sophisticated system is there, and very soon the tunnels which we normally used to see in outside India would be possible to see here in Mumbai also, and subsequently hopefully in other cities also. So yeah. So talking about the details of the TBM and the tunnel, you can see the typical cross section of tunnel. It is finished diameter is 11 meter, and this is 2.07 kilometer each tunnel. I'm talking about the bore tunnel, otherwise it is total 4 kilometer. Then we have got precast rings, which are 2 meter wide, 375 millimeter thick. And the carriageway, you can see this is the carriageway, which is comprising of 3 lanes, and it's 3.2 into 3. So the third lane is considered to be emergency purpose. And there is a box you can see in the below, which will be used for utility purposes, for pipelines and electrical cables, communication cables, etc. Rest portion will be filled here, and then there will be the rigid pavement will be made over here. And yeah, that is all. And it will be constructed by this board TBM. Talking about the geological conditions, it is breccia and basalt, and to some extent shale and clay is also there. It has its own challenge of being near to the sea. So it's not just the only the soil perspective, but also you're seeing the perspective of the external, which is the tidal variations also. It does have affected while our mining and our drive was happening. Then there is overburden, which is as low as 4 meter to as high as 68 meter. Low overburden has its own challenges, which we had a lot of lessons also learned. And then it crossed under numerous heritage buildings also. Some of them were like 120 years old also. So, and besides that, no need to say it's in the middle of the Mumbai, South Mumbai, that too. And there are a host of logistical factors which did make the life difficult for us, but then we are moving ahead. And the choice of TBM was slurry TBM. Why? Because there were other issues. As I mentioned, there are a lot of geological variations were there. Breccia, basalt, shale, and nearness to the sea. Besides the this buildings are there. So over a point of lot of deliberation, we've chosen slurry TBM over the EPB. Although we were thinking about EPB also. These are some of the data of what all. I have already spoken about it, just for that. At one place it is mentioned here. The weight of TBM is more than 2,500 tons, and the power is enormous, 7,326 kilowatt. The length of the TBM is 80 meter, and it is since it is 12 meter dia, so it has got its 2 decks are there, and it's plenty of space. Had it been a smaller dia, it would have been longer TBM, but then it's all within that we have put accommodate. And you can see there are 24 jacks, and they are able to produce more than 100,000 kilonewton of thrust. That the peak thrust is that. Maximum stroke length is 2 meters. This is how the schematic of TBM looks like. This is the cutter head, and it's almost like a 3-story building. When we stand here, we are like, and the MSV which is carrying the segments go below this this thing, the first deck. Taking up the geological conditions and their impact, you see it's near to the Arabian Sea here, and both sides. This is the Priyadarshi Park area, and this is the Juhu Chowpatty, beg your pardon, this Marine Drive Girgaon Chowpatty, which we called. And this is Malabar Hill, which is where our 68 meter overburden is there. And there are a lot of buildings over here on the alignment itself. And here is one swimming pool was there just before our retrieval shaft area. So all these were a lot of challenge. And then within the city, how do you maneuver? So that was also a challenge. This is the geological profile, which you can see. We have issues of cutter head clogging also because of this presence of shale and this clay material. This is the Priyadarshini Park area's photograph. Here you can see the sea here, and this is a ramp and the curtain cover, and then the TBM portion is starting at the end towards the south side, and it just goes below these buildings towards the Chowpatty area. And also we have all this segment yard was within this area only. That made our logistical issues much simpler. We have put our batching plant, our casting yard here itself. So that way we can, we have used this area which we have reclaimed. Earlier the sea water used to come over up to here. It is intertidal zone. We've reclaimed it, and that way it was logistically it was helpful. Some of the major hindrance to the tunneling was that due to COVID, at the time of the peak of COVID, the TBM came to India, and that point of time we didn't have any support as far as from OEM is concerned, or even a lot of permissions were not available. For example, to take a blasting permission to dig our launching shaft. So, so these were the challenges, and what it was looked like that the project is going to completely go out of hand. But at that point of time, we did some innovative thoughts, and that's what we're going to share with you. And what we did was we decided to assemble the entire TBM at the ground itself instead of putting inside the shaft. So we started with this. Of course, it's going to take we assume that 50 to 60 days it will take. But if had it to be done inside the shaft, probably more, and there are very high capacity cranes would be required, because each and every components are quite heavily weighted. Like cutter head itself is 330 tons. Rest all I will show you later. So this was planned, and then we have selected this mechanism of strand jack technique, which is normally used for shipping and other places. So, and it has a huge capacity of 5,000 up to 5,000 tons of lowering. So we have started assembling, and then we move through this SPMTs. That is self-propelled modular transport vehicles. And then, in fact, this shield, if you see, this is 1,500 tons. this particular shield. Cutter head is 330 tons, and the backup gantry is from 300 to 500 tons. We have also done to save the time, the recovery of time is by rotating the TBM, because once the retrieval shaft at the Girgaon Chowpatty, the TBM, when it breakthrough happens, we earlier thought was that to dismantle it, transport it back to Priyadarshini Park, again lower it, again assemble it and launch it. That would have taken a lot of time, but then we have made it as a risk mitigation plan of our own initiative. And this is the one of the heaviest turntable mechanism which we have made in-house, completely in-house. It has got this jack system which will, instead of propelling the TBM straight, tangentially it is turning so that the TBM can be rotated. This is scheme by scheme. You can see this is the breakthrough happened, then shifting, then the turning, and then it's near to that second shaft, second drive. Apart from that, recovering time, we have also put focus on operational excellences as to where all the time can be saved, because it has got certain, mining is there. Then there is being a slurry TBM, it has got a crusher installed inside the TBM. It crushes, then disposal of slurry, then a lot of these logistical things quite common. But then we have tried how to save the time on that, and there also we succeeded in saving the time. And yeah, this is just typical glimpse of what are the activities that there, how much time it took. So on an average, it was 2 hours, 20 minutes, 30 minutes. When our logistics, our everything was perfect, then this was what we have got. Of course, we have got much poorer performance than this also, but this was one of the cases. And I'm happy to share that on the month of July last year, we understand that it was the biggest, highest progress in a month, which is 456 meters, 0.724 meters in a month. And this was the peak week progress and daily progress what we have got. Within this diameter, it's considered to be the highest in this kind of TBM. Of course, in the rock TBM, it would be probably higher than this, but in this urban environment and this kind of things. This is how the logistic looks, the site utilization plan looks like. So this is where the Gurgaon Chowpatty is there. There is a road here, and there is a railway line here, this Arabian Sea here, and we have to plan everything within this vicinity only. Again, the importance of better utilization plan, which made it possible. Sorry. And whatever muck spoil what we used to get, we because of the slurry TBM, we have this STBM, this segregation of aggregate was possible, and that was very good kind of material which you used to get, and it was used for reclamation purpose also at our locations. MSVs was used to transport the segment, and the other challenges were from the land and this thing acquisition point of view. It was a challenge, and then a lot of these heritage buildings, more than 120 years old, 150 years old buildings were there. Just below this alignment used to happen to go below that. And I will just show a video here just to connect. So we got this breakthrough done, and then thank you. We got this breakthrough done, and once we rotated the TBM, within 75 days of time, we could relaunch it, which was otherwise expected that it won't take less than 130, 140 days. Like 4-5 months of job, we could have do it in barely 2 months' time. So that is where, when the need comes higher, I mean, when the requirement is higher, the innovation helps us, and that's what I'm proud of my team. And on behalf of all my team and all, I would just like to, I'll just take another 40 seconds. Okay. Could be full. This is how, when all the teams come together, they can overcome the challenges, and this was proved. And very soon, the connecting to the South Mumbai portion to the Bandra-Worli Steel Link will be a reality. There are, of course, elevated bridge portion is also going on, which is having its own kind of challenges. And we are trying to do that by latest by this year end, or maybe next year, early next year. That is our efforts are there. And thanks to all of you for having your patience hearing, and thank you. Right.
Thank you for an excellent presentation on various aspects of this tunnel. Twin tunnel of 2072 meter each and 12 meter dia, how you are constructing and sea, and very close to vicinity of sea and Marine Drive. So with that, now we come to the next presentation, that NHAI tunnel experiences, and they are overcoming extremely challenging geological conditions in Ramban Banihal, which has been mentioned by various other speakers also yesterday, and Pando Takoli. So Mr. Amrendra Kumar, Chief General Manager, NHAI, will make the presentation.
Respected Chair and Co-Chair, and all dear colleagues present in the room. My presentation will be, you have heard so many experts in different fields. My presentation will be what is the experience of an employer or authority. That will be basically concentrated on that. And we have chosen the two stretches. First is overall, what is the NHAI tunnel experience. That is the overall view. And another is two stretches where we struggle the most. Ramban Banihal section in J&K and Pando Takoli section in Himachal Pradesh. We all know earlier we were not very comfortable with tunneling. Wherever requirement of tunnel is there, we generally as an employer used to avoid it. And reason was that it's high cost. It was the first and foremost reason. And another was lack of experience, or something that is not known to our highway fraternity at that time. Investigation, design, construction, all were, we were lacking experience. But the things have changed, and nowadays large scale tunneling is being done. And wherever requirement of tunnel is there, I can very confidently tell that that we are adopting that solution promptly. And many where there is alternative also, but due to some environmental reason or any consideration, we are preferring this tunneling. And Jawahar Tunnel is the first tunnel that come as a legacy to NHAI. When this Jammu Srinagar section was transferred to NHAI, then Jawahar Tunnel, duly constructed tunnel on Pir Panjal Rain, has come to us. It is 2.59 kilometer and it's operational since 1959. But it was in higher altitude. Since it was in higher altitude, so its operation was marred with snowfall or so, and NHAI constructed another tunnel at much lower altitude, that is Kazikund Banihal, and that is operational nowadays also. And the first tunnel that is of significant length has of 10.89 kilometer has made operational by NHAI in March 2017. To substantiate my words that we are nowadays, wherever tunnel is required, we are going for it. There are 24 number tunnels. It is a picture of entire national highways, and more than 50% of this, almost 2/3 of this is being done by NHAI. 24 tunnels of 42.55 kilometer is already operational, and tunnel under implementation is 47 number, more than 100 kilometer length. And much more is under DPR stage, and it is of only 1-2 years data, so there is much more. And how tunneling has solved this problem, that we can give you by 2 examples. Jammu-Srinagar distance was earlier 320 kilometers. And with the help of these 27 number tunnels that we are planning, or most of them are already operational, this has reduced to 250 kilometers. And this will reduce not only 30 kilometer of traveling length, but it will reduce travel time to 7 to 8 hours. And not to say that vehicle operating cost will be saving in this direction and reducing the carbon footprint also. Similarly, this another Kiratpur Manali road that we are having earlier, its design length is 237 kilometer. But that is being reduced to 190 kilometer with the help of 14 number of tunnels. And this 19.5 kilometer length in saving, this will have a saving of 47 kilometer, and saving time will be 5 to 6 hours. And another example that we are preferring this, and other agencies are also insisting NHAI for this tunneling, is 8-lane tunnel in Mukundra in Delhi-Mumbai Expressway is being planned. And otherwise it was being think that how this sanctuary and wildlife highway will be constructed in that region. Then 2 stretches, Matheran Eco-Sensitive Zone also 3.3 kilometer long 8-lane tunnel is being planned, and that is the graphic representation. And coming to the specific of this Ramban Banihal section, while designing this originally, we were conceived of, it is of 36 kilometer stretch originally. When we have 4-lane it, then it has come to 34 kilometer or so, and it was initially it was envisaged 5 number of tunnel with 2.5 kilometer aggregating length. Subsequently, it is found that in the 3 passages where we are conceiving that by hill cutting or providing some RS wall or retaining wall in valley side, we will be able to do this 4-laning work. That was not feasible. And seeing the site condition, promptly NHAI has engaged a DPR consultant for this, and we have come out with this 7 more tunnels aggregating to 16 kilometers. So this 36 kilometer is now reducing to 32 kilometer only. But the timeline to complete this stretch is significantly increased. This is Ramban Banihal. It is in Jammu Srinagar section, and if difficulty of this part Ramban Banihal is shown in this geological longitudinal section. You will see here it is a Muri thrust, it is near Pira village, and Panjal thrust. These are the 2 thrusts within this 36 kilometer stretches, and there are 2 sub thrust, local thrust also, making this entire stretch very challenging. All that type of as I have shown you in Muri thrust and Panjal thrust, along with the Digdol and Makarkot thrust, this made this stretch most challenging. All the geological problems were aggravated due to this, and almost 400 to 600 meters of exposed means the peak level height, and our planned highway section has a means there is high mountains that is remain exposed, that is making it susceptible to slope disability and rock falls, etc. And the slopes are also plunging towards the existing road. This aggravating this problem. All type of critical issues we have faced: landslide, debris flow, stability and slope failures, rock fall, geological structures, seismicity. It is in zone 4. These are the 19 specific points where this problem has been noticed, and out of that the solution were based on economical or feasible. First the slope protection were attempted. If it is not, then viaduct was attempted, and subsequently in 2 locations, or rather 3 locations, tunnel were planned. That was the only solution. So at 2 places, additional long tunnel has been provided, and along with some viaduct. This is the first stretch that we call Marog Digdol. It is called as a package 1. It has 4.1 side tunnel length is 4.5 kilometer, another side it is 4.3 kilometer. Problem was that hill cutting that was envisaged earlier for widening of the road, that was not feasible, and the alignment you are seeing is that generally that doesn't happen in tunnels because of this. It was the afterthought that the level of both the end were fixed. So to maintain the gradient, we have to have this type of alignment. These are under construction now, and to have a feel that these are the locations of portal. This is the southern portals, means for northbound carriageway we are defining as a northbound and southbound. For northbound it is a entry portal, and for southbound it is the exit portal locations, and similarly it is for another side portals. And another location where it is in continuity, Digdol to Khoninala, another long tunnel was provided, and it is in the range of 2.6 kilometer and 3 kilometer stretches, and these are the also showing these portal locations and their geological condition to have a visual feel of that. First part, it is a learning with respect to this employer perspective. DPR should have all geological and technical studies done much earlier, and even if it is done, the tunnel proposed earlier was not adopted or it is curtailed because of the cost constraint, that eventually we have to go for delaying this project, and we have to be very fair in DPR, all the studies being done, and where to adopt what proposal. That should be given importance, not cost cutting justify every means non-feasible or unpractical solutions. While execution contract administration, we have to learn that we should be fair and timely decision is to be taken. This is the one case where probably NHI was prompt in taking decision and DPR was DPR consultant was mobilized at earliest. And another example that will be showing you, that is a classic case of non-decision in from the authority side. And it is my personal view. We have discussed also risk allocation, etc., etc. Then first thing is, while DPR, we have to be accurate in DPR preparation. All these studies done, and as accurate as possible we have to be. And while defining these schedules in DPR preparation, we have to mention it accurately. NHI is generally following the EPC, BOT or HAM projects, where we are defining our scope by in different schedules. Then we have to be, that defining of schedule should be accurate one, and wherever defining schedules, the payment schedules, that should have corresponding payment schedule also. Like no vague words like slope protection in this region without giving detail, and there is no supporting payment schedules, then it will not work. This will lead to disputes and non-decision at later on, and after delaying this. NHAI has adopted a classic case for risk allocation of this underground that we have discussed, and probably many of you might be knowing also, and if we are not being adopted by other employer, then it needs to be adopted. Since we all know whatever fair means studies we do, rock classification accurately cannot be done. So based on our study, whatever rock classification in certain length has been done, that we provide in a contract, and if it is in variance with that, then what is the changes, either excavation cost changes or support system changes, that based on that difference in cost changes, we provide a matrix. If this length from rock classification 3 to 4 comes, then this will be the cost change. We provide a factor. This is inbuilt in our contract, and this is providing a lot of convenience to our contractor also and employer also in handling these such matters. And another stretch I have told you earlier, it is in Himachal, Pandor Takoli section, and in this the DPR or bid document that we have provided, there was 2 tunnels that lengths or portal locations were totally off the mark. That was this means deficiency of DPR level, and CUS handling of this CUS has taken almost more than 1.5 years in NHA, and that was the unfortunate part. We should have not done, but finally it is the present Chief Secretary here that was earlier chairman to us also, under his guidance that it has settled in conciliation and CCI that we call. This is the Sapurji Palanji is contractor in this. It is already ongoing work, and this is the equivalent of that geological mapping here. You will find in law, this is the Mandi, and near to Mandi, this is the end of this tunnel is end of this project also. So here also you will providing taking that some thrust lining or that geological. This is the brief scope of that project. There are series of tunnels. The 2 lines says that is twin tunnel is there, and single line is saying this one tunnel, and odd tunnel is already constructed in this stretch that will be used for new structure also. There are 10 new 2-lane tubes tunnel aggregating length 19 km, 4-lane stretches and connector, and these are the details that apart from these elevated structures. This is the elevation and plan of these tunnels proposed in this. It is primarily all tunnels project, 2-lane cross section of that tunnel. Difficult approach to tunnels. This cut and cover was provided at the start of this any one tunnel. This is to explain you how this DPR has been bungled up. This the stretch where portal is proposed at this location, in actual it is 183 meter cut required. That is not feasible. So length of this tunnel requires to increase by 249 meter in this direction. This is the one challenge, this change of scope that requires in this section. Another was that is promptly we have to acknowledge that whatever accurately we do DPR also, probably we cannot capture entire details in entirety. There was a large HRT going on parallelly, and this red line is proposed as this tender provision. These locations were provided. Later on, contractor has submitted this change. That tunnel length was remaining the same, but due to this, elevated structures was being increased. So I will give means not entirely fault of a DPR consultant, but we have to be open to these such type of surprises during execution also. and we have to take appropriate decision at appropriate time. This is another changes happened here due to pure geology and open deep cut. That location portal locations were need to be changed, and that leads to the increase of the tunnel length. Apart from that, this construction challenges that faced by the contractor is chimney formation, cavity formations, and these are the pictorials. Cavity formation under picture, and high fracture loose mucks were enclosed. Pipe roofing was done to this rescue this cavity formation, grouting in cavity area. These are pictorial space for this. Muck disposal was when this cavity formation has so much mucks comes, removal of this is also become a task. And support system needs to be provided in. These are the few slope protection, extensive slope protection required at these stretches. These are pictures of how this after construction this looks like. One thing that employer needs also that whenever this tunneling work done, quite a large amount of muck get generated. Either we plan subsequently highway in adjoining region that uses required some land, and along with that forest clearances also. If we plan it in DPR stage only, that will save time during execution. But this is the learning that we have learned after some delay in project implementation. But nowadays we are adopting this. Electromagnetic work for needs also extra land that were not very largely appreciated by authority earlier, but within that land and from this grid supply is required. Also needs a quite long length of connectivity. These are few other pictures of providing. Already part of this stretch is already can be made operational. It is in trial traffic, can be made operational. These are the pictures of the control room. Nowadays, SCADA system is provided and control rooms are there. Key learnings from the execution part is proper topography and geological survey should have been done, and adequate land to be acquired for the muck disposal and aerial. Continuous investigation is required by during construction also for the contractor also. It needs WAPRO drilling, etc. Standardized by dynamic variable designs for rock support to be before execution. New way of executions, we should be open for that also. Here contractor will explain, he is present here also. Liquid explosive were used for controlling outbreak. Use of new technology such as polyfiber in shotcrete and concreting were used. Consider sprayed concrete in final lining in good rock condition. These are the few tweets made by our Honorable Minister for these projects. Key learning from all these, I will say that we have to be very fair while accurate while preparing our DPR, and while contract administration, we have to be very fair and balanced, and this will save our day. With this, I complete my presentation. Thank you.
Thank you, Amrendra, for bringing out the very important NHAI projects. In fact, NHAI is one of the largest implementing agency for road projects in the, I think, in the entire world. They are executing a large number of projects. NSDP program was also that time a very large project, and I think in PPP also they have a very vast experience. In this particular, they have taken up in this presentation the employer's perspective. I think there is also need to analyze about the decision making and whether the timely decision has been taken, whether delays were there in the decision making, and how it can be improved, because there is a cost and time overrun in large projects. And then there are large number of claims. That is also very important when we are executing such large projects. So unless you have a timely decision, so that is another important area where I think they should bring out in the future case studies that whether there was delay and what was the reason for those delays, so that we can have takeaways from this kind of experience, which they have a vast experience in their projects. Thank you very much for this, their experiences in tunnels. Now I come to the next presentation, that is a 57-kilometer long railway tunnel between Lyon and Turin under the Alps. By Lucy, please.
Good afternoon. It remains a great honour to be here with you today with such eminent panel and audience. Thank you. I'm Lucy Roux. I'm the project director for the engineer on this particular project, which is the 57-kilometre railway tunnel between Lyon and Turin under the Alps, and it will be carrying goods vehicles and high-speed trains. I'll give you a quick introduction to the project. I'll talk about the risks, what we already knew before we started, how we designed for these risks, and then I'll talk quickly about the works. The historic Fréjus Tunnel, the original line that we're replacing, was opened in 1871. It was at the time the longest rail tunnel in the world. You can see it as the yellow line in the bottom left inset image. What you can not see accurately though, but I assure you that there were some sections that were up to 27% slope. It was a single track tunnel, two tracks in one tunnel, and it wasn't very optimal. So in 1992, France and Italy decided to collaborate on a new tunnel, the Mont-Cenis Base Tunnel. This new high-speed rail line from Lyon in France to Turin in Italy will be 270 kilometers long, of which 202 kilometers will be in tunnels. There's a common section between France and Italy, from Saint-Jean-de-Maurienne in France to Susa, Busoleno in Italy, which includes the 57.5-kilometer long Mont-Cenis Base Tunnel, comprising 2 one-track tubes, and also involves the excavation of 4 access adits and 4 6-meter diameter 500 deep shafts that are currently being constructed by the raise bore technique. I described in my presentation yesterday the initial geological investigations, which included directional boreholes. We also discussed why it was not possible to get more substantial information regarding the base tunnel from the surface, and that different methods were required to gain essential knowledge of the geology. This knowledge we have now gained, thanks to this project, has confirmed the feasibility of the whole project and has allowed us to develop the methods to safely construct the rest of the project through what is very challenging ground, and probably the most challenging ground to have been tunneled to date in Europe, if not the world, but I don't know. After the 2002 directional boreholes, we excavated 4 down adits to the level of the base tunnel between 2003 and 2010. The adits in themselves were part of the geological investigation, and they also gave us access points from which to carry out further boreholes, starting closer to the base tunnel than we could do so from the surface. The third level of investigation, which I described yesterday, is the contract Saint-Martin-la-Porte 4 because it's the 4th contract from this down tunnel, where we excavated 10.4 kilometers of the base tunnel through the most complex geological ground of the project, as I said, proving the feasibility of the whole project. This 3-step investigation process was essential to reduce the risks, thus releasing financing for the further steps of the project, and to develop safe methods for the excavation of the parallel base tunnel through the same formations. On the graph, I don't have a pointer, but if you go from the left, you can see the down tunnel that I'm talking about, where it says Saint-Julien-Mondeny. That's where this project is that I'm talking now. So what did we know before we started? This you may recognize is some geology. The initial work at the Saint-Martin-la-Porte site that we carried out between 2003 and 2010 with the construction of the 2,380 metre long decline access tunnel. On the figure, you can see the access adit. The thick black line represents what we constructed during the contract SMP1, and the red line represents SMP2, which was diverted away from the original trajectory, which should have just been a straight line that would have finished perpendicular to the baseline tunnel. We made this diversion to avoid the most difficult geology. Saint-Martin-la-Porte 4 is the first contract excavated in the axis of the project. The contract was divided into 4 operational parts. Parts 1, 3A, 3B and 4 to be excavated by conventional methods, so a mixture of drill and blast and mechanized excavation. And part 2 we did with a tunnel boring machine, a TBM. The geology is complex and enclosed in 2 main formations. If you look at the very top of the slide on the left, the blue section is the ZSB, the zone sub-briançonnaise, which is a marly limestone, massive limestone and calc schist. To the right, we have the ZHB in the brown colours. This is the zone huilière briançonnaise. From east to west, it has arenaceous and black shale with coal levels to sandstone and conglomerates. The ZSB changes gradually to the ZHB, passing through an overlapping tectonic contact called the Front Huilier, the FH, that's the yellow section, a highly carboniferous tectonized formation. Parts 3A and 3B are inscribed in the ZSB and directly inside the contact between the Front Huilier and the Zone Huilière Briançonnaise. This is the most challenging ground that we were certain could not be constructed with a tunnel boring machine. We knew that the convergences would just be too great and the machine would get stuck. Part 2, excavated by the TBM, and Part 4 are in the middle of the geological units of the Zone Huilière Briançonnaise. So what we knew already was what we had discovered during the construction of SMP1 and SMP2, the down adit. These works allowed us to update the geological profile, which we then used to design the SMP4 works. You can see in the 2 graphs, the top one shows the provisional geological long section, and the one underneath shows the actual geological section. There are significant differences between the provisional and the actual geological profiles. The findings from the access adit excavation work showed us that the complex and specific nature of this particular geological formation that we encountered. Boring work related to this access adit encountered quite exceptional difficulties when crossing the so-called productive Huilier terrain, a coal formation, brown coal. These difficulties came in the form of very high amplitude convergence phenomena in a sector in which the thickness of the overburden terrain was moderate, less than 300 meters. On the next slide, we can see what these convergences actually look like. This photograph was taken in the SMP2 down adit. What you can see are convergences of over 2 meters in the tunnel diameter and a multi-phase construction sequence where we allowed the ground deformation to occur. before reaming out the finished diameter. You can't stop the ground from moving, it's much stronger than we are. We installed a rigid support 80 to 90 meters from the face, and that's the steel section you can see at the front of the photo. So what we needed to find out with this SMP4 project so that we could determine the feasibility of the rest of the 57-kilometer tunnel, we needed to verify the geological assumptions. And by the way, this slide is in the booklet of the conference, so you've got all the information there. We needed to specify the geotechnical data concerning the productive houiller at the level of the base tunnel. We wanted to acquire the experience required to excavate the rest of the base tunnel using a TBM. We needed to determine the characteristics and adaptations required for the TBM. We needed to adapt the excavation section, geometry and mechanical characteristics of the lining segments, analyze the behavior of the terrain that we were going to cross and the forces to be supported at the houiller face and in other areas. We wanted to consolidate the working methodology based on the conditions encountered, and we wanted to explore any karst areas and underground water movements in the vicinity of the base tunnel. As I said yesterday, karst can contain vast amounts of water at very high pressure. And we wanted to test different sealing and terrain consolidation products in the delicate area. So that's what we knew before we started. Now, how do we design for these risks? On this slide, we can see the works that make up the SMP4. The main information from this graph are the overburden up to 700 meters. You can see that in the section, the rectangle in yellow at the top of the slide. That shows the section that this contract deals with. The section excavated by the TBM, that's the long yellow rectangle partie 2 in the middle of the slide. And everything else was excavated by traditional methods. We can also see the very tricky front houiller. That's in the middle of the bottom half, the brown section. And then we were able to transfer the project that we were going to be excavating in the following works. Studies carried out during the construction of the 4 access adits helped improve knowledge of the terrain. In addition, these access adits are also used to excavate the base tunnel on several fronts, and once the tunnel has been commissioned, they will be used for ventilation, maintenance, and emergency service access, if that was required during the operation of the project. For the TBM drive, the lithostratigraphic sequence to be crossed was well known. However, the sector is characterized by a large topographic overburden between 700 and 1,200 meters, and so there was difficulty in extrapolating from the surface geological and structural observations. And in the slide, I've listed the uncertainties that remained: the nature of the faults, the fracturing, mixed faces, variability of the inclination of the schists, and the presence of high hydraulic loads and water ingress. We approached several TBM manufacturers. So when I say we, I'm talking about the engineer and the client. This is before the contractor was involved. One of them, NFM, was prepared to study the design approach to a TBM that could handle the specific characteristics of the ground to be excavated. This process took place in 2009. The input data we gave NFM included the length of the tunnel, the excavation diameter, the cover, the maximum slope, which was 6.5%. We didn't know the alignment yet, but we were able to give details of the geology and the possibility that we would pass perpendicularly through the coal formations that could be several meters thick. The expected convergences were in the order of only 10 to 20 centimeters, so this shouldn't have been too much of a problem. We knew there would be faults, water ingress, a risk of gas, and the abrasivity of the ground could be high. NFM recommended the TBM technical specification that we then incorporated into the contract requirements. I'm not going to go through this, you can read it in the handbook. The excavation, now I'm going to talk about the conventional method section, part 3B. So this is nearly 1.4 kilometers of the base tunnel that we excavated as a reconnaissance tunnel in the final diameter of the project. So there will be a train running through this one day. Part 3 was excavated using the conventional method, and it crosses the coal formation of the Sub-Briançonnaise unit, the anhydrites of the Willier face, before entering the productive Willier unit. These formations usually appear without continuity and in a highly disrupted structure, giving rise to major convergence phenomena requiring specific systems to control the deformations and stabilize the structure as well to protect the labor force. Safety was quite a high priority, as it is in all our projects. We implemented the observational method by inputting the data collected from the complete advanced drilling of cord and destructive boreholes in the face. So we had continuous advanced drilling. We used the daily analysis of the convergences and our experience from the Access Adit works, SMP1 and SMP2. A finite element 3D back analysis allowed us to validate the models. We developed an excavation technique for dealing with the convergences in 3 phases. So we installed a temporary support with an increasing rigidity over these 3 phases. Phase A is the immediate support, and we installed a highly deformable support that could accompany the ground movements, made up of a large amount of peripheral, long resin-sealed self-drilling rock bolts and sliding TH ribs with fiberglass bolts in the face. Phase B, so that's a semi-rigid support, we carried out at a minimal distance, normally 25 to 30 meters from the face, where we excavated the invert and installed HID con blocks, that's the make. They're highly deformable concrete blocks that we installed aligned with the sliding sections of the ribs, allowing the shotcrete to deform in line with the sliding of the ribs. And then we implemented careful shotcreting of the ribs to make sure that they could still slide. You don't want to spray shotcrete where you need them to move. Then phase C we applied, if necessary, after the stabilization of the convergences, with the objective of guaranteeing the minimal internal diameter in 15 years' time, which is the maximum expected delay until the final lining is concreted. And in fact, this phase C, we constructed over 333 meters of the tunnel using a purpose-built tunnel lining formwork. I'll just quickly run through the works because I don't have much time left. We constructed between October 2014 and October 2022. About 4,000 meters of the tunnel and cavern were constructed using the traditional method and 8,700 meters by TBM. We constructed a cavern for assembling the TBM. The cavern is much bigger than the tunnel, as you can see on the graph bottom left, as there has to be room for the gantry crane and the assembly of the TBM. We also constructed a cavern for dismantling the tunnel boring machine, and you can see in the transverse section of the cavern the temporary support and the excavation phases. These were really long rock bolts. We constructed the TBM drive in 3 years. We had difficulty traversing 2 particular faults that took about 6 months. We had to carry out a lot of ground improvement by grouting ahead of the TBM. Fortunately, this was something that we'd provided for with the TBM, that we should be able to drill ahead of the face. There was some ovalization of the rings, and we had to install an additional internal support system, which you can see in the top right photograph. We had to carry out 2 exceptional maintenance procedures to repair and replace the cutting tools that were damaged by the blocky ground. These took 4 months. Very difficult working conditions, as you can see from the photographs. We constructed in the traditional method part 3A, which was a supplementary down drive to the base tunnel so that we could have access from both ends of the Front Willier. We had some base heave due to the presence of anhydrites that swell in contact with the water. That's what you can see on these photographs. And then we constructed the Part 3B through the Franc-Williers from January 2017 to March 2022. So that's quite a long time to excavate 1.3 kilometers of tunnel. The main difficulty was the highly tectonized Carboniferous Willier face that I described earlier. It took 5 years to do 1.3 kilometers of tunnel. And why did it take so long? Well, we installed about 500 meters of rock bolt per linear meter of tunnel in the most converging sections. It just took a long time to do. Here you can see some images showing the progressive stiffening of the supports. So the two figures to the left show phase A. The two central figures show the inverts and spraying in between the ribs in phase B, and in phase C you can see the blocking ring, the fully rigid support. We also had the ability to reduce the section when we needed to. The bottom right figure shows the various different sections that we could design for. And you can see in the two photographs the big section then coming down to the reduced section and then a small section. This was the most difficult part, where we had about 1.3 meters of convergence. So the top right photograph shows the original excavation of the small section, and the bottom left section shows where we're destroying that to bring out to the full size of the large section. I haven't written a conclusion, but I think you could say that if you fail to plan, then you plan to fail. And you need to know what your risks are so that you can adequately manage them, finance them, and predict what's going to be happening throughout the phase of the project. Thank you.
Thank you, Ms. Lucy, for a very detailed presentation on this project. And before I ask my co-chair to wrap up, I think we can take a couple of questions. Yes, please. Mike, yes.
Hi sir, I am Rituraj from Orica Mining Services. My question is to Amrendra sir, that you had in your slide you had recommended to go for liquid explosive, or it's called emulsion explosive. So my question is that sir, have you used emulsion explosive in these hilly terrains? And another question is that sir, we are always going for digitization, for advancement, to change the new technology. So in blasting, we always go for conventional method, just like for using package explosive or electric detonators or non-electric detonators. Sir. So when we go for new technology in blasting methods. Okay. Thank you.
Please.
I have given an employer's perspective. Concessionaire for that project is also CEO of that concessionaire is available. Whether he like to answer this liquid explosive part.
I think there is no hand on that side. Okay. Yes. Yes, please. You provide mic. No,
so अंदर क्या पूछा?
चलो anyway. Okay, we is not willing to answer.
By the time I would like to share with Mr. Sandeep. Just you talked about the monopile concept, monopile foundation, right? I think this is a good concept, perhaps, and this is the first time that perhaps you are using. Then my question is this, that are you going to take the stability in YY direction? If it is in XX direction, there is no problem. But how to take care of in YY direction? Because its stiffness is tremendously, it will decrease. Because shear strength of pile is very, very less with the compared to the vertical load and vertical stresses. And are you going to give in this monopile concept a pile cap, or straightway you are taking the pier on the monopile?
Yeah, thanks for this question. Yeah, so the monopile concept actually is more famous, or it is more prevalent in where we have got this windmills are there. So there already there are a lot of forces, horizontal forces are there. I'm just giving a perspective that it is derived from there. And as far as the design is concerned, that particular designs are already considered in this our bridge portion. Second thing was that pile cap part. Pile cap is not required in this case. We can straight away build up the pier, and that is what saves time, especially in the environment where we are making a sea bridge. Because in the land portion, it is still easy to make a pile cap, but in case of sea, where you have to make a cofferdam, or you have to make a lot of secant piling might have to be done. So that way it is useful, and we can straight away. As far as the design is concerned, it is considered on that. And in case of very high tower of this windmills, it is already considered for the shear forces also.
But in this case, its slenderness ratio will be high. Therefore, I am asking that if there is a pile cap, then its slenderness ratio will be under control. Then is it possible to share the design? I'll give you the email so that I am interested to see this concept.
We make, yeah, you can share me the email ID and we can talk.
You can share
offline.
maybe in
Yeah,
the last time.
Sure.
Okay.
I have
Yeah,
a
yeah.
question for Mr. Amarendra, sir. Hello.
Yes, yes, let him.
Sure.
My name is Amresh Srivastav. I am chairman of a company, Novafil, which is making this new technology product, polyfibers, for concrete reinforcement. So my question is to Mr. Amren Kumar. I have been to Ramban, sir, and I have experienced the difficulties which you have faced. So it was an excellent presentation of the problems faced by you and solved by you. But my first question is that your presentation is not available in the souvenir. All other presentation is available. So how to get it?
We'll provide you. Don't worry.
Yeah, please.
Okay.
That is one.
Yeah.
Second thing is, this new technology products, for example, our polyfibers, what Indian Road Congress or NHAI, they are doing it to encourage it. Because most of the cases, there is a little mental blockade, and only the new smart people like Mr. Sumit Jain of RVNL and many other people, they are using it. But in many cases, I find that it is very difficult. In hydro tunneling, HRT and TRT, it is not being used. In Arunachal and Assam, Sevak, Rampo, it is not being used. And in the railway, NFR, also it is not being used. So how to promote this product? This is an import substitution product, and we are making it here in India with an American brand. Technology is there. We are trying to do the import substitution. But the blockade is there, and we are not able to bring it to India properly. So I want your comments, sir.
Not to this specific new technology, but in general, since NHI is adopting either HAM model or EPC mode, where this design is done by concessionaire, it is their prerogative. And NHI, Ministry of Road Transport and Highway, has this guidelines also to promote this new technology and providing this incentive also, and it is in big way. So there is certain mental block is still there, but we are continuously, means wherever this new technology proposal comes, then we are also convincing the authority engineer they have to make payment. Field officials also are encouraged to try new technology, and we are open, means we are gradually improving, and certainly we will improve further.
Thank you very much.
Okay. Yeah, I have a question for Mr. Sandeep Saram Lere Gupta, Technical Consultant for Ministry of Road Transport and Highways. So you talked about the iterative process of selection of TBMs. So, is it audible now? So you talked about the selection of TBMs through iterative process. So was the change from EPM to slurry done through modeling, or what are significant parameters that were used to arrive at this conclusion?
Okay. So it's not modeling is not used particularly for this. There are a lot of historical data are available. Prior to we selected this TBM, we had information of 17 TBMs were already working in Mumbai Metro. So we have, and it's quite a contra kind of decision, because out of 17, 16 were EPB, only one was slurry. So one is that historical data is there, geography, hydrogeological conditions are there. Second is that what are my constraints here in this case. For example, one of the cases, this is the bigger diameter TBM. It's not regular 6 meter. So a lot of muck will be coming out. So slurry would be a better way to deal with that kind of muck, that we thought. Apart from that, the material can be reused for backfilling purposes, which is a major hurdle in case of transportation of that spoil. Apart from that, the other things were like the buildings were there, and we have a better control in slurry TBM as far as the phase pressure is concerned, and that is one of the strong reasons of going towards it. Although geology-wise, it's as far as the basalt is concerned, it's this regular EPB is sufficient. With open mode mining also you can do, but there was patches of breccia and there were patches of shale intrusions also, that too near the buildings. So we have considered overall safety and responsiveness for the TBM over this factor, and then we have gone for this slurry TBM machine.
Thank you. I have one more question for Lucy Ru, if you may allow. You said about that a certain allowable deformation is allowed in the tunnel. So what is there any percentage or any parameter or any document that you refer to come at a conclusion that X amount of deformation, X percent of deformation is allowable in a particular tunnel lining, like in a final lining?
You can sit down now, please. Oh, sorry. Yeah.
So the question being how much convergence we could allow before the final lining was executed?
Yes.
Okay, so we because we knew we were going to have quite large convergences and there would be a problem with creep, we excavated a larger diameter than we needed. So the calculation that we carried out was looking at the areas where the convergences were still moving. They were probably only moving 1 or 2 millimeters a day, but over 15 years, that's a significant amount of convergence. 1 to 2 millimeters a month, not a day. So that would have given us between 200 and 300 millimeters over the rest of the duration until we concreted. So we knew that if we were going to be going into the diameter, the maximum limit that we could allow, that was where we built the blocking ring. So that was only over 330 meters of tunnel where we knew that there would still be too much convergence before the final lining is implemented. Does that answer the question?
Yeah, thank you so much.
Yeah,
we have already overshooted by half an hour, so maybe 1 or 2 questions maximum.
Yeah,
and then you can have interaction in the lunch time.
My question is to Lucy, ma'am. I'm Pratap Patil calling from Forbes Marshall, Pune. So I just wanted to know that so long length of tube, let's say 57 kilometers. So what kind of ventilation system you have designed it, or any in between shafts are there for emergency?
I'm sorry.
In the final project?
Yeah.
Yes. Okay, so at about half distance along the tunnel, there is a safety station, and at that safety station, there are 4 ventilation shafts, 6 meter diameter, 500 meters deep. That is the main ventilation.
Okay. And across the tube longer length, more than 10 kilometers, what type of ventilation system is designing?
I'm looking at my colleague, Frédéric Vermel, who is our ventilation expert, and he can answer that question if he can have a microphone.
Okay, meantime,
Along the normal tunnel section, it's a push-pull ventilation systems. So we use the shaft to push fresh air and to extract the smokes. With a longitudinal ventilation, achieving a critical velocity along the tunnels. Then people can evacuate on one side, and we have, I think, cross passages every 350 meters to evacuate from bore to bore.
Okay,
thank you.
Sanjeev, please, last question. You give mic here, this side.
I'm Sanjeev Kumar, Director, Indian Academy of Highway Engineers. First of all, I want to make one observation that quality of DPR, it is very important and it's a backbone basically for creation of sustainable and good facility. Somehow, we have seen in India the quality of DPR is not up to the mark. There are various issues, and to my understanding, there are three critical things which can produce better or quality DPR. One is the personals, key personnel, their knowledge, their capacity is very important. Another thing is the timeline. How much timeline should be given for preparation of DPR? And especially for tunnel projects, because we don't know what is hidden under the ground. So we should give adequate time for survey and investigation and preparation of the DPR. And third thing is the cost. What should be the cost of the DPR preparation? In one of the presentation we have seen, if the costs incurred for preparation of the DPR, the risk cost is reduced, minimized. In case it is more than 6%, 6 to 8%, then these are minimized. So my suggestion is that from this forum, as a way forward, can we recommend some sort of a guideline, though each project are unique, complexities are unique, but can we suggest or can we evolve some guideline for our employer, for our government, which can be followed for preparation of the DPR, especially for the tunnel? What should be the timeline? What type of people should be there? And then what should be the cost? So this is my first this thing. I don't want answer, but I have a suggestion that maybe if committee think appropriate, IRC think appropriate, we can give sort of a observation, recommendation. Then I have a question maybe from Lucy or Sandeep Singh. See, about the quality of the concrete, the homogeneity, consistency, and the grade of concrete, whatever we have envisaged in our design for precast panels. We have seen in last couple of years, several bridges in India have failed, have collapsed during construction. There were various reasons, and one of the reasons was that the grade of the concrete that was checked in the failed precast member, it was much, much less than the grade envisaged in the design. Though all the cube tests that were performed, their grade was much higher than the envisaged in the design. But in the actual member, grade was much lower or lesser. Because ultimately, the grade of the concrete which is there, which is present in the member, which plays the significant role towards the life of the facility. So my question is there any mechanism to ensure the quality or the grade of the concrete that has been casted in the member, precast member?
Would like to answer?
Yeah, I will take it. First of all, sir, about the concrete is concerned, we are doing the concrete work at coastal road, which is very near to the sea. So all the more the durability considerations are more stringent because it is sea breezes are there. And for that purpose, we are using this GGBS. This is GGBS has got an excellent, and it's proven through various literatures are there on that. And it has a good, not only in RCPT value, but also in terms of this chloride and sulfate, it's a good resistance towards that. That's one as far as the durability is concerned. Second one is, okay, the design part I'm not touching, but the design teams are there who just make what is the requirement. For example, we are doing M60 grade of concrete in our tunnel segments as well as in bridges also. The second part is about the aggregate selection, because that's very important. What kind of aggregate we are having, what sort of workability, because if the vibration is not proper and the trained people are not there, that is the good concrete also will fail. And the mold also plays the very good mechanism if the entrapped air or the vibration of the mold is taken care. So all these things we have zeroed down in our work. And as a result, wherever even surprise tests we have done, so we have found it's to be okay. Design part I'm leaving, maybe Ms. Lucy can talk.
I think because there are a large number of still interested questions, but we are already overshooted. So I am giving the most difficult task to sum up the entire proceedings to a professor in 5 minutes. So I am asking my co-chair to summarize the proceedings of all the three presentations.
Okay, Mr. Nirma, thank you very much. So I could enjoy all of the presentations and exciting presentation and active discussions. So the three presentation is different topics, and I think there are some problems I solved. So the first one, so Mr. Sandeep talk about the TBM in India. So maybe your country will develop and rapidly. So maybe the diameter of the TBM increase gradually. So maybe we need to pay attention to the select between the EPB method or the slurry method. So because in Japan we have 75% of EPB method currently, and we need to pay attention to the volume of the excavation and also maybe the diameter increasing. So we confirm the accuracy of the construction. So maybe something like the circular diameters. And also maybe the length of the TBM tunnel, so under the sea, so maybe you should confirm the evacuation route. So you need to connect the tunnel or divide the section for the evacuation route. So in Japan we have some TBM tunnels, and we try to combine the several TBM tunnels using the conventional method. So maybe the maximum diameter is about 2,000 square meters recently. So maybe it may reflect on the construction result on your country. And the second one, Mr. Kumar, so talked about the experience in mountain area. So maybe, as you know, the tunnel in mountain area is quite resistant to all of the weather, snowy and rainy and so on. So maybe we confirm the importance of the drainage, so the water inflows inside the tunnels. And we also avoid the landslide and rockfall. So maybe we cannot stop landslide after the excavation or the compression of the tunnels. So that we, in advance, avoid the position of the landslide through the investigation. And Mr. Kumar talked about the polyfiber shotcrete and the sprayed concrete final linings. So maybe the good new technology. But we analyzed the mechanical characteristics regarding the polyfiber, because the polyfiber is a little bit short strength for the shotcrete. And sprayed concrete lining is hard to confirm the quality for the waterproof. So maybe we need to tackle with the program for the normal usage of the tunneling. And the last one, Ms. Lu, thank you very much. I heard I appreciate this example of the longest railway tunnels in European countries. So maybe we also in Japan have the same problems because the TBM is constrained by the very, very soft ground. So we also need to develop the technology to investigate in front of face with non-destructive method. So it is quite hard, but we need to avoid the constraint and confirm the speed of the TBM. And maybe the very large deformation influence on the maintenance and the use of the tunnels. Because if the cross section is small, becomes smaller and smaller, maybe we cannot confirm the limitation of the section for railway and other truck or car vehicles. So in Japan, we have periodical inspection every 5 years. It is mandatory from the central government. And we check the deformation if the trouble occurred during the constructions. So maybe your country will develop the regulation by the central government about the inspection and the maintenance. Thank you very much.
Thank you, Co-Chair, for relating this, summing up with the Japanese experience also. So we had very excellent presentations of all the three speakers and then very live interactions, and I think still there are many queries. So I will request you to have your queries discussed maybe during lunch session or maybe afterwards with the presenters. With this, I declare the session closed. Thank you.
I request all the members and the dignitaries present here to kindly be seated. May I now respectfully ask Shri Sudeep Chaudhary, ADG Morth, to make his way towards the high table and offer felicitation to the distinguished members. Chair S.K. Nirmal, Secretary General IRC and former DGRD and SS Mort. Co-Chair Professor Nobuharu Isago, TC 4.4 member, Japan. Mr. Sandeep Singh, L&T, India. Mr. Amrendra Kumar, CGM NHAI. And Ms. Lucy Ryu, Aegis ITA member, United Kingdom. Thank you so much, sir. A parallel session on case studies on road tunnel project part 2 will be conducted in the seminar hall of the Vishwasarya building, which is a 5-minute walk from here. Now I request all the dignitaries to kindly proceed for the lunch on the ground floor at the reception. We shall continue with the session at 14:45 hours. Thank you so much. there. With this belief in our hearts, we have reached the final presentation of the day. This session will be led by our chair, Shri A.K. Srivastava, ADG retired, MOT and convener, H10 Committee IRC, and the co-chair, Mr. Ricardo Miranda, Pi Arc TC 4.4 member. I request the chair and the co-chair to please proceed towards the high table. I kindly request Mr. Manoranjan Misra, Engineering Chief, Works Department, Odisha, to head towards the high table and bestow felicitation upon the chair and the co-chair. Now, I would like to direct the attention of our guests to the order in which the session will be held. There will be 3 presentations by the experts, the first being on the design concepts of road tunnel against earthquake in Japan by Professor Nobuharu Isago, Pi Arc TC 4.4 member Japan. The second will be on the topic long subsea tunnels by Mr. Adriel Sovik, Pi Arc TC 4.4 ITA, COSIF member Norway, and the final presentation will be on Zojila Tunnel Project by Shri M.S. Diol, Executive Director NHIDCL. I kindly request all the presenters to proceed towards the high table.
Nice, Ricardo.
With this, I hand over the procession of the meeting to the respected committee. Thank you so much.
Thank you. Welcome to all speakers today, and perhaps this is the last presentation of today's marathon meeting and presentation. And first presentation is on design concept of road tunnel against earthquake. Perhaps this is very important to have presentation on this subject, because in India there are certain zones which are having 5 and 4, and tunneling projects are going on in that zone. Therefore, this will be very useful from the Indian perspective, tunneling aspects. Second presentation is for long subsea tunnels. In India also, in Mumbai, Greater Mumbai and all. And recently it has been in that one under river tunnel in Calcutta, railway metro tunnel has been opened. Therefore, there is a lot of this scope for this undersea tunnel, under river tunnel in India. And we are also planning to go for this type of tunneling, apart from tunneling in Himalayan regions and other regions or other hilly regions. Therefore, from that angle, it is also very useful for us, for the participants. And lastly, Zojila Tunnel project, which is perhaps the longest tunnel in India, which is 14.15 kilometer long, and which faces a lot of challenges also. That from the morning session we are discussing about the risk and challenges. Therefore, this tunnel faced a lot of challenges from the beginning, because location of portals, avalanche problem, because portal was on height, and how to connect it. First, you will have to viaduct bridge is to be constructed, then portal should be heated upon, and all that. Therefore, it will be perhaps all these issues will be captured in his presentation, and it will be very informative also, that how we face the challenge and how we have overcome this. I think with these words, without losing time, then I should invite first a speaker, Mr. Ishago and Mr. Kushaba Azusi. Perhaps both of you will give the presentation 50-50, okay? Okay, then you will keep in mind the time factor also, so that you can share. Okay, thank you.
Hello everyone, so I'm Nobuharu Isago from Japan. So I talk about the design concept of road tunnel against earthquake in Japan. Maybe the main topic is based on the experience of Japanese damage or accident. Okay, so before presentation, I found the interesting picture. So because this travel, I traveled your country, this is the second time. So my first travel is about 11 years ago. So I could meet Mr. Srivastava in the picture, the left side, and next to me. So I met him about 11 years ago. So maybe your friend may see may know someone in these pictures. So I found this morning. And today, so back to the agenda. So I talk about the road tunnel structure in Japan, and the next one is the example of road tunnel damage by earthquake. And next is dynamic measurement at existing tunnel. So we measure the strain and the acceleration during the road tunnels. And the last one is the practical countermeasures against earthquake. So after the big earthquake, Ministry of Land, Infrastructure and Transportation in Japan announced the document regarding the countermeasures of the earthquake in road tunnels. So firstly, I talk about the network of road in Japan. So in Japan, we have 4 categories about road tunnels. So road, and the one is the highest one is and the second one is the national highway, and the prefecture road, and the municipal road. So the as I mentioned about the announcement of the government is reflect on the national expressway and the national highway excluded about the prefecture road and the municipal road due to the limitation of the budget and the technical problems. But the length is about, in road is about 1,212,000 kilometers. And also in Japan, we have road tunnels. We have many road tunnels. About number is 11,000.
and the total length is about 4,700 kilometers as of April 2020. So I don't know the recent data regarding the railway and the water tunnel in Japan. I'm sorry, but the data was quite old. But as of 2007, about 10 or 15 years ago, the railway is about 2,300 and water is about 4,700. So maybe the Japanese total for the infrastructure is about 10,000 kilometers all over the countries. Maybe we enter the road tunnel so that we can see the such sectional shape, maybe the lighting or some roads, pavement, and so on. But as you know, the structure is quite, the outer the tunnel is such this. So the ground and the support member is sprayed concrete, steel arched supports, and rock board. Maybe if the ground is poor, so we constructed inverted arch downside the tunnels. And also, we have a permanent lining inside the temporary support to keep the safe or to have some functions against uncertain issues. And this is the example of the tunnel structure for two-lane road tunnels in Japan. So the support members consists of the sprayed concrete, rock board, and steel arched support mainly. And also, as I mentioned, permanent lining is made inside the temporary structures. But the permanent made of plain concrete, not reinforced concrete in ordinary areas, except Portal area. Portal area has a single river in Japan, but the plain concrete is mainly used for the ordinary areas in tunnels. And also, maybe the sprayed concrete, rock board, steel arch support, the specification is different and depends on the ground conditions. And we also have the 6 support members patterns regulated by the government. So it is mandatory for the contractors. And if we need to change, so maybe the contractor and the government official discuss the necessity of the changes. And 6 ground classification are shown B1, C2, D1, D2, and D3A, the 6 type. So that this section you can see is the C2 pattern. Consists of the sprayed concrete rock board and steel arch support. Not we have the inverted arch concrete in C2 pattern. Maybe the adopted for the fair ground. Maybe the normally good conditions. In Japan, we have C2 pattern is about maybe the 30 or 40% of the ground in Japan, and the D1 pattern is about 50 or 55% in Japan. This is the outline of the tunnel structure in Japan. And the next, the topic is a little bit different, but I'd like to introduce the earthquake in Japan. So if the earthquake happened, we are very surprised. So the Japan Meteorological Agency, so maybe they broadcast weather every day. So they broadcast the report or the emergency news after the earthquake occurrence. So the JME announced the seismic intensity in 10 grades. So you can see in this PowerPoint, you can see the 7 grade. From 0 to 5 upper, 1, 2, 3, 4, 5 lower, 5 upper. So maybe the intensity 0, maybe everyone cannot understand the occurrence of the earthquake, but the fine earthquake meter can detect the earthquake. And one is maybe that some sensitive person can understand the occurrence, but most of people cannot. But 2, 3, 4, so maybe we can understand the occurrence. Maybe the 4 is, you can see the lighting is very swaying over our head. And 5 lower and 5 upper, maybe the bookshelf is turned down, and we need to escape under the tables. And also 6 lower, 6 upper, 7 is quite a big damage for the structures, not only the tunnel, but also all civil structures. Maybe the 6 lower and 6 upper, maybe some old house may have some collapse or damage. And the 7, it is quite the biggest seismicity intensity. Maybe the building and many houses have some cracks or the broken windows. And this is the frequency of earthquake in Japan. So 7 is, as I mentioned, the greatest, and 1 is a very small earthquake. But as you can see, the 7 is about twice or third times during 10 years. And the 6 plus 6 minus is about every 1 year in Japan, not in some region, all over in Japan. So you can see that 2011, the 7 is the first. This is, as you know, the East Japan big earthquake, so that 20,000 people was died by the tidal wave, big tidal wave in Japan. And 2016, we have 2 big earthquake. It relates to the damage of the tunnels, and we have a lot of damage about the tunnels. And 2018, so we don't have any damage about the road infrastructure. So maybe we have 1,000 or 2,000 earthquake in Japan every year. But the 2011 and the 2016 is a quite much number. But this result from the the aftershock of the big earthquake. So this is a picture for the tunnel damage by the earthquake. The left one is 2004. We have a Chuetsu earthquake, the damage of the Wanatsu tunnel. So maybe you can see the collapse of the permanent lining. So it fell down inside the tunnels. And also the right picture, this is Tawarayama tunnel in the Kumamoto earthquake. It occurred in 2016. The person, 2 persons are shown in the picture. The one is me. So I needed to investigate the damage of result as a governmental official at the time. So maybe you can see the collapse of the concrete. So the depth, the thickness of the permanent lining is about 30 centimeters in Japan. So this thickness is almost 30 centimeters. So luckily, so we have no damage, no fatal damage for the person, because the earthquake occurred around 1 a.m. in the midnight. So no traffic in the tunnels. And also 2004, the left side of the Wanatsu tunnel, we don't have any human damage relating to the tunnel. Certainly, this earthquake occurred on Saturday, maybe at the evening, 5 p.m. or so. But fortunately, no car in the tunnels. But this is a national road, but no cars at that time. So it is quite lucky for us. And this right side picture, so the permanent lining was collapsed, and we peeled all over the permanent lining and the water membrane. So we can see the big shear cracks over the temporary lining. So you can see the big cracks over the shotcrete, and the steel arched support is bending by the earthquake load. So maybe this displacement is about 100 millimeter, 10 centimeter. And if that 10 centimeter difference of the permanent lining, so the temporary lining, so maybe the permanent lining may fall down into the tunnels. In this tunnel, so we can other damages. So in the same in the same tunnel. So we can see the tunnel has some heaving and some collapsing over the ceiling. Maybe because the axial force along the tunnel, so maybe something like the tunnel is pushing, and the floor is heaving, and the ceiling is collapsing, and fell down, the concrete fell down into the tunnels. So maybe you can see the line is something like the skewed under the mounting, and maybe you can see. Also, we have some shear cracks around this over the tunnel. So small debris we can see. But as I mentioned, we have no fatal damage or human damage from this earthquake. So the fatal damage. So I introduced some pictures. I introduced you some pictures. But the fatal damage in tunnel is frequent. So empirically limited, this earthquake intensity is 7 or 6 plus. So this is the maximum level of the earthquake. So the quite rare earthquake also in Japan. Maybe as I talked to you, so maybe the once in 10 years or so. But so in Kumamoto earthquake 2006, so you can see the collapse of the permanent lining. But the area has totally 8 kilometers length of the tunnel over 6 plus intensity. But only few segments, so maybe you can see the 2 or 3 pictures was damaged. So the area is quite limited. So we may conclude the tunnel is strong against earthquakes generally. But how much so do we invest for the countermeasures of the tunnels? So we need to check the dynamic movement of the tunnel. So because we need to know the basic actual mechanical behavior of a tunnel during earthquakes. So we pick up the 2 tunnels, Tunnel A and Tunnel B. So the Hokkaido area and the Tohoku area. Tunnel B is near the East Japan earthquakes. So this is the dynamic measurement installation of the measurement device. So we directly attach the acceleration measurement device inside the tunnels. The pace is quite normal, so not special conditions, very, very normal. So maybe the support pattern is C2, so that maybe the most frequent support pattern. And the measurement B, so measurement at tunnel B, so we also measure the strain over the permanent lining concrete. So this is a very simple figure. We check the strain and the acceleration. So the acceleration is surface of the tunnel, and inside the ground we set the acceleration meters. So this is a result of the acceleration inside the tunnel and the outside the tunnel, so near the weather station. So the horizontal axis is the acceleration at tunnel, and the vertical axis is near weather station's accelerations. So maybe you can see the weather station of the acceleration of the weather station is quite bigger than inside the tunnels. And also, we check the seismic intensity inside the tunnel and the weather station. So we can see maybe the 1 or 2 point different intensity between the 2 points. Also, we calculated the frequency and the strain of the tunnel, and we can measure only the 10 or 20 micro, because this is quite small strain inside the tunnel. Maybe the maximum collapse compressive strain is about 3,000 or 4,000, but only we have the 10 or 20, maybe the 1% of the collapsed strength. Maybe the almost the same tunnel A and tunnel B. So this is a major conclusion from the measurement. The seismic motion at tunnel is smaller than that on the ground surface. Also, the seismic motion around the tunnel is almost the same with the tunnel. And the strain of tunnel lining is the elastic range because it is quite small, so that we don't have any damage normally or generally. So we conclude as a government so that no additional countermeasure is needed for road tunnels in ordinary, normal ground condition, not a special condition. So the tunnel is in extremely poor ground conditions should be examined apart from this examination and measurement. So we also performed some experiment to simulate the movement of the permanent linings. The left one is the plain concrete, and the right one is fiber reinforced concrete. So if we push the great load, so we can see the fall of the lining specimens. But if we performed the rebar inside the tunnels, so maybe this is constraint. This is stopped by constraint of the rebar, so it can stop the movement of the permanent lining. So rebar is good for newly construction tunnel, but damage example is quite limited. So how do we think? So it is quite a difficult problem. So the ground condition prone to earthquake damage we examined. So that this is the following 8 conditions. It may occur the great damage of the permanent lining from the extreme water flow during the construction, large collapse of cutting face, and unstable ground which requires a massive auxiliary method, and so on. So this is quite bad ground condition if we need to pay attention. So newly constructed road tunnels, so we also perform the inverted arch concrete and rebar inside the permanent lining. So we can avoid the critical and fatal collapse for the tunnel collapse during the earthquake. But it is quite difficult for the existing road tunnels because in Japan we have, as I mentioned, we have 10,000 road tunnels extremely constructed, already constructed, so that we need to fill the void behind the permanent lining. Also, some reinforcement measurement to attach seat or rebar and so on. So we need to continue studying the effect of the reinforcement measure. And also in my university, so we perform the small specimen test repeatedly, again and again. My students try to one. And the safety of the tunnel portal decreased within the increase of slope angle, and it was influenced by the minimum distance from the ground surface. So the slope angle and the distance, we should pay attention if we need to avoid or minimize the damage from the earthquake. So the tunnels in extremely severe condition for portal and the priority for countermeasures should be examined in near future. So we need to issue some document from the government and so on. Okay, this is rough study result and the measurement result. So thank you for your attention. ありがとうございました。
Thank you, Professor Isago. Mr. Isago is involved in a teaching profession there, and his subject matter is tunneling. Therefore, he is having a very good background of design of tunnel, especially in earthquake. And thank you very much for your excellent presentation. Thank you. Now, next, should I invite Mr. Sovik? He is from Norway. He is also a member of PEARC Technical Committee. ITA, and Norway is having a very good experience in the tunneling. Yes, Mr. Souvik, please.
Thank you, Mr. Chairman, and thank you for having me here. Dear gentlemen and ladies, my speech today is about long subsea road tunnels. Yesterday we learned about Uttarakhand is the land of gods. Maybe Norway and Japan is the land of tunnels. And certainly Norway is the land of subsea tunnels. That we can have. I have a background from as a national tunnel manager in Norway, responsible to follow up all the tunnels in Norway, road tunnels. That means also follow it up during planning and construction and making the safety approvals and the approvals for continuing the construction, but also before opening. I have experience from both the client side as an expert advisor, but also from the contractor. So I've been sitting on all sides of the table, more or less. I will give you a short introduction, then I will say something about cost-effective designs, operation and maintenance, an important prerequisite when we plan tunnels, why subsea tunnels, and then we will have some engineering, geological investigations, ground treatment, and difficult conditions. First of all, I also represent something called ITA COSUBS that aims to be the center of excellence of worldwide exchange of information and know-how regarding safety and security of underground facilities. And that is very relevant when we come to long subsea tunnels. What is also interesting is that I'm representing something called the Norwegian Tunneling Network. This is a cooperation between leading tunneling actors from Norway. That means that in our network we have universities and research organizations, advisory and consultancy companies, but also contractors and product and service suppliers. So we have all the experts, and I'm their network director for that activity. As I said, when it comes to long tunnels, if we make a comparison in Europe, you can see that we have actually more than 65 tunnels longer than 4,000, more than 4 kilometers. We have the longest in the world, like the Lærdal Tunnel, that is 24 kilometers long. And right now, as we speak, under construction is the Rogfast Tunnel. That is a subsea tunnel that is 26.5 kilometers long. Our philosophy, I will say, that is our strength. Cost-effective design, construction, and operation. We have a history in thinking cost-efficient development. This is because of the nature of Norway. We have to reach out to every island, we have to reach out to every area and all the regions. That means that we have to think about cost when we are building this. But we also have a lot of experience in building also in city areas. This has led to an experience with the largest, longest, deepest, and most complex projects in the world in both rural areas and populated areas. And we plan to break all records in the coming years. So the Rogfast subsea tunnel, 36.5 kilometers, double tube, 300 meters below sea level, but it's also connecting island community into that tunnel, so we have one less ferry connection as well. Opened in 2021, we opened the Ryfylke tunnel, that is 14 kilometer double tube tunnel, that is also a subsea tunnel in the same area, and this is 291 meters below sea level. The first subsea tunnel in Norway was built in 1983, 2.9 kilometers, 88 meters below sea level. So in total, we have exceeded over 40 subsea tunnels in Norway. A lot of these tunnels have an incline up to 10% in these tunnels, and I will say something about that as well. When it comes to cost-effective design, requirements that ensure the right level of investment, that is very important, and this is something the road director said to me many times. Traffic density, characteristics of the tunnel, and a systematic evaluation of RAMS criteria and risk decides the design of a tunnel. It is important to be able to invest in a cost-efficient road network suited for both city and rural areas that balance the investment on open road and tunnels, considering traffic safety, but also the other risks in a systematic way. So this is very important. So what is cost-effective project implementation? Regulations that differentiate between low traffic and urban high traffic tunnels. That means we need to have an appropriate design, number of tubes and cross sections is decided by this. Choose of tunneling method that is best suited for the geological conditions, but also other factors can influence. Choose of safety ventilation strategy based on acceptable risk and best suited for cost-effective design and operation. So for instance, we are using a lot of longitudinal ventilation in our tunnels in Norway. That is a very cost-effective design. A cost-effective way to implement control and monitoring systems, that means that we have only 5 centers, traffic control centers in Norway. A cost-effective distribution of these traffic control centers and a cost-effective operation and maintenance into contracts is always important. A few words about ramps. Tunnel construction and installation can have weaknesses that can affect reliability, availability, and maintainability and safety. This is something we have seen the last years. Tunnels with weaknesses largely affects costs. Lifespan of construction and installation in many cases give high socioeconomic cost in terms of more frequent shutdowns and less available road network. So for instance, we have examples in Norway where we have to take a total rehabilitation of the tunnel already after 15 years. This is something we have worked with a lot the last years, so we will meet these criteria in a much better way. We also have a lot of experience when it comes to different safety issues in the tunnels. So we have learned especially a lot about the subsea tunnels because they represent also an incline that gives us a different risk model when we come to these tunnels. So in the tunnels in Norway, in total, 2 fires a month, and 40% of these fires are in 4% of the tunnels in Norway, and that is the tunnels with incline. But what we see in these fires is, in most cases, there are no damage. It's handled in a correct way. But in these subsea tunnels, we have seen some incidents that really have frightened us a little bit. Steep climb before or in the tunnel give an increased risk of technical problems in larger vehicles and is the main cause of fires in such tunnels. High speed when driving into tunnel can also increase the risk, technical problems, but also the lack of knowledge on experience on the driver. So this is something we need to take in mind when we are designing these tunnels, because we don't want to go past the incline of 5%. And this is something also the EU directive says. And also these directives says that this risk will increase already by an incline of 3%. So why subsea tunnels? One of the reasons is to connect regions. Road, ferry connections, bridges, and tunnel are alternatives in this. By combining knowledge and experience from the oil and gas sector with known and new bridge and tunnel technologies, we know that today we can technically cross any of the Norwegian fjords anywhere. Better predictability and accessibility is good for all transport and improves the framework conditions for business and export-oriented activities. Reduced travel time between cities, local communities, and regions contributes to increased productivity and value creation. Housing and work markets are getting larger, forming new and overlapping living and work regions. There may be also other good reasons for not choosing the shortest route, but technically this is possible. So for instance, we have something called the coastal highway route in Norway, where we would like to have it a ferryless route. And what is shown in this picture is all the crossings we need to do in this project. So we need to find out what to do in these cases. So we have three alternatives. We have the ferry, we have the bridge, or we have the tunnel connection. Feasibility, future traffic prognosis, future development of society, but also cost. And cost is a very complex picture because it's not only the investment that many of the project managers are just interested in, but it's also operation, maintenance, socioeconomic impact on society is also part of this. So for instance, a ferry connection have a very low investment cost, but have a high operational cost. But a bridge have a very high investment cost, but a lower operational cost. For a tunnel, it has, it is not as costly as a bridge connection maybe, but it has a higher operational and maintenance cost. So this is something we also need to consider in this. We mentioned Rogfast as a connecting region project, replacing 2 subsea tunnels, 2 ferry connections, including the local community of Kvitsøy. So in this case, it's both connecting regions, but also a local community. A 4-hour travel time route diversion around this project. So if we close this tunnel in the future, the availability is very important here in the RAMS analysis. So availability is certainly a key element for this high traffic straight crossing. That means that we have to look at solutions on this particular tunnel that make sure that we can actually keep the traffic still on in only one tube when we are doing something else in the other tube. And that might be an accident or it might be maintenance. Then we have a lot of examples on connecting local communities. Located on the west coast of Norway, connecting small communities to the mainland of 2,700 inhabitants on these islands. This is the Nordøyveien. The project is located mainland connection and ferry replacement. District road financed by the district and toll loan by the Norwegian Parliament. The project is assumed and daily traffic in the first collection year of 693 vehicles. That is not a very high traffic. And an annual growth in the traffic volume on only 1%. The cost limit in this project was 5,600 million Norwegian kroner. That is $600 million US. If we look at this project, it is 3 subsea tunnels. Originally, they asked us to build this as a 10% incline. We sent a letter, you are not allowed to do this, and this caused, of course, a lot of trouble the next months. But we find an agreement, and then we decided to build these subsea tunnels with a little better incline. This project in total took 3 years to build. And if you see the numbers here, you can see how fast we can actually build these kind of projects. When it comes to engineering and geological investigation, ground treatment, and difficult conditions, it is important to handle risk fair and correct. That means that the contract you are setting up is very important. Tunneling is inevitably associated with handling on uncertainty and risk. We have had several presentations these 2 days that clarify this. Risk associated with geological conditions can be significant, and in subsea tunnels in particular. Unexpected geological conditions are too often claimed, so it goes to conflict. Each underground project is unique surroundings, geologic owners or organizations, and so on. Therefore, risks to be dealt with are also unique. So that means one size fits all may not work in tunneling. Contract must be unique. What is also very important when we are performing the Norwegian tunneling method and the Norwegian way of working is that we have a very close cooperation and continuously decision-making between the contractor and the client, very much in the front of the building. That ensures a very cost-effective production. That means that we need very clear rules on how to handle, for instance, unexpected geological conditions. So this will support then a very fast forward production of the tunneling. So you see here a typical fjord where the gradient, the incline must not exceed these 5%. This means that we have to find the right length of this tunnel, for instance. So if this is a very deep tunnel, we need to find a proper length so we don't maximize this incline. Optimization of the minimum rock cover is always a key factor in the planning of subsea tunnel projects. Excessive rock cover will make the tunnel unnecessarily long, causing effective construction cost as well as increased operation and traffic costs during the entire lifetime. Insufficient rock cover, on the other hand, may cause severe stability problems and unacceptable risk during excavation, as well as large water inflow, which may require very comprehensive grouting and considerable water pumping. This may have very serious economic consequences, and in worst case, there may be risk of losing control with the stability. So there is a high focus on the max gradient incline, but also on this rock cover. In order to analyze the significance of minimum rock cover, basically 3 methods have been applied. Analysis of maximum progress of potential cave-in, numerical analysis of water inflow as function of rock cover, but also empirical analysis based on experience from completed projects. For many of the completed Norwegian subsea tunnels, the minimum rock cover is less than 30 meters. In the few cases where signs of instability have been experienced during excavation, the rock cover has been relatively large. So here we see an example of the geology of the Rogfast tunnel, where they are now doing the construction. So, of course, we had a lot of discussions when it comes to this maximum incline. So that meant that we had to make this tunnel actually 500 meters longer than it was originally designed for. We have also a lot of experience when it comes to investigating the ground conditions in this project, and we used oil and gas technology to actually do this, and marine technology. So we are pretty much in the forefront in these kind of investigations. But we have done this for many times, for many years, and we have a lot of documentation on how this is best done. For this tunnel, the Frøya tunnel, we are often using this as an example. Pre-construction site investigation indicated very difficult ground condition, included weakness zones with heavily crushed rock, sand, and swelling clay. Tunnel excavation started early in '98, and due to high quality investigation and planning, as well as continuous follow-up during excavation of the Frøya tunnel, this was completed with excellent results in late 1999. So, for long subsea tunnels are located deeply under sea and give us more difficulties in geological investigation, design, construction, and operation. In the planning and design stage, carefully pre-investigation is of critical importance. Extensive marine seismic refraction survey is the major method for investigating bedrock profiles and detecting fault, weakness zones, and depressions, which are major threats to the tunnel stability. Directional core drilling from onshore passes geological structure and obtain rock cores. Direct evaluation of the rock condition can also be provided there. Special rock support methods are needed in order to pass such weaknesses zone, including reduced blast rounds, bolt-enforced shotcrete ribs, and dense long spilling bolt. The lining of Norwegian subsea tunnels consists typically of spray concrete and rock bolts for support and freestanding inner lining for water and frost protection. That means that this is not a construction that is load-bearing. The lining is designed as a drain structure, sustaining no external water pressure. Cast-in-place concrete is used in extreme adverse geological condition. All subsea tunnels in Norway are excavated by drill and blast method. Ground freezing is an alternative in difficult ground condition and is used to stabilize weak ground conditions. Here is a reference to one of the companies that is experts on this. Inflow of seawater is one of the critical issues for subsea tunnels, since there is no natural exit for the inflow water, and it is essential to know the geological and hydrogeological conditions ahead of phase. Probe drilling and pre-grouting technique are the best way to detect the water inflow and reduce it to the acceptable level, but also be ready to meet new severe situations. The minimum rock cover is an influential factor to the tunnel stability as well as economy and should be evaluated very carefully.
Mr. Søvik, 2 minutes more.
I will not go into the details on probing or growth injection, but it will be a part of this presentation. But very shortly, I will say a minimum rock cover of 23 meters has been used, despite the Norwegian road tunnel standards requires more detailed geological investigation and special analysis if the minimum rock cover is less than 50 meters. So that means that we are challenging these 50 meters. Problems related to in-leaking saline water, such as erosion of shotcrete and metallic parts, are specially used for subsea tunnels and need to be coped with seriously. In the last 30 years, rich experience have been gained in Norway from construction of more than 40 subsea tunnels, and the Norwegian subsea tunneling concept has been formed. Our experts on engineering and geological aspects are the Norwegian Technology University, it's the research organization SINTEF, but also Norwegian Geology Institute. But I will also say that the whole industry of advisors, consultants, contractors, and product and service supplier is also part of that experience. So I will use this moment to tell to you that I am not expert on all these matters when it comes to the subsea tunnels, but I am the single point of contact into the Norwegian industry. That means that you can contact me and we can make sure you get the answers you need. And probably we can also start a dialogue that can lead to a collaboration between Norwegian experts and Indian projects. So please, thank you.
Thank you. Thank you, Mr. Soik, for excellent presentation, considering the cost-effective aspects for the tunneling in your country, comparing with ferry system, high-level bridges, and tunneling. Thank you very much. Now, next and last presenter, Mr. M.S. Goel, who is Executive Director of NHIDCL. He will share with us his experience on Zojila Tunnel.
Thank you, Chairman, sir. Eminent panelists on the dais, colleague engineers, tunnel professionals, ladies and gentlemen.
Can you adjust your mic so that your voice should be more clear?
A very good afternoon to all of you. Last 2 days has been very exciting technical deliberations on tunneling matters, which has made us more wise and aware on the subject. I shall also be presenting an overview today of Zojila Tunnel, which is being constructed by NHIDCL, a PSU fully owned by Ministry of Road Transport and Highway. As the beginning of the session, Chairman has already mentioned there was a necessity of providing some seamless connectivity in the form of a tunnel in that area of Himalayan mountain. This tunnel is not only going to give a lifeline to the people of Ladakh, but also be a game changer as far as socio-economic development of that region is concerned, which has been neglected for quite some time. This project was also referred by our Honorable Minister of Road and Transport during the inaugural session of 2 days back, when recorded message was videoed here, sir. Now coming to the brass tacks. If you see, those who know the geography of that area, Srinagar to Leh is approximately 400 plus kilometers, and it is available to drive during fair weather around 10 hours or so, provided your vehicle is mechanically fit. There is no weather changes en route, and you can travel medically fit in a high altitude area. This was the basic genesis of one of the reasons why there is a seamless connectivity required. When we talk of selection of mode, whether it's a tunnel, whether it's a road, whether it's a bridge, whether it's a waterway, here we had no choice. If anybody have any objection to that, then he is welcome to say. We have no choice in this 12,000 to 18,000 feet from mean sea level, which is covered 8 months in a year. Tunnel was the only option. Now, tunnel in isolation was also not an option. It was a complex option, which during the course of my overview, I'm going to cover it. If you go further, there is a place called Gagangir, which is close to the, which is 72 kilometers from Dras. Between Gagangir and Dras, it is 70 kilometers, and high mountain ranges are there. So this is the place where we require a complex solution, that is a combination of small tunnels, bridges, cut and cover, etc., that we have conceived, which we're going to speak, sir. Now, if you see the general climatic condition, as I have rightly brought out, maximum temperature goes 30 degree, and that to a very short span of 15 to 20 days in a year, and minimum goes to minus 27, which stays 3 to 4 months over there. Average annual snowfall is 2.7 meter. As I speak here, it is snowing over there, and yesterday also there was a 20-meter snow head at one of our vertical shaft. I'll be showing you the video at the end of my presentation that will actually give you an actual glance of ground situation in this particular project. This is the picture which shows in what condition the vehicles are traveling. This is in a fair weather condition. The kind of road you can visualize. The passing places are minimum. The safe stopping distance, side distances are not available. So tunnel was the only option over there. These are some of the clippings which I've taken from the various newspapers or Now, if you come here, you see after the snowfall is over, it requires a Herculean task to reopen, which includes not only snow cutters, dozers, it also costs human life sometimes. And this is this is basically not cost effective. If we have a technology available as we have been deliberating, then tunnel is the only option. So this huge task can be done away with, and cost effective in long run can be, and break even period can be worked out without any doubt, without any confusion. So all the economics of this, providing this tunnel, is in favor of making this project, although we have delayed quite a bit till date. Now here is a small clipping which you can see. This is not a very old clipping. This is an avalanche which has come 14th of January, if I'm not wrong. If you see, both this avalanche has been taken for the same site with two different cameras. There is a speaker, I have put it on mute because few people are shouting to save themselves. It will not be in good taste to show that thing, not to create any fear here. As you see, as we are discussing, in order to provide round the air connectivity, this 44-kilometer stretch between Gagangir and J&K and Minamarg in Ladakh. The other side is Union Territory of Ladakh. This place has been identified to be developed as a tunnel, snow galleries, deflector dams, bridges. Deflector dams and bridges are part of it to economize the cost of the entire project. This entire project has been divided into two parts. Part one is the Jedmore tunnel, which has got around 13.5 kilometers. It has got 6 kilometer approach road and 6.5 kilometer of tunnel, which has got 10.8 meter diameter, supported by another 7.5 meter diameter of escape tunnel. And Jojila tunnel, which is that project, is approximately 38 kilometers. Out of that, 17 kilometer is initially road, and then followed by Nilgara tunnels, two twin tube tunnels, and then 13.15 kilometer of single tube bi-directional Jojila tunnel per se. As I have necessity, I have already discussed. I'm sure you all have got convinced that terrain of Jojila Pass is highly treacherous. Lot of fatal accidents happened every year, and if it is completed, we will save not only human life, we will save cost of vehicle operating cost as well. This will provide round the year connectivity between Valley of Kashmir, Ladakh, which will be vital for the development of Ladakh, promotion of tourism, free movement of this thing, and also for the strategic reasons, and our armed forces, because 7 months in a year, our forces and the people of Ladakh are supported only by air, and the cost of the air is well understood by all of us. In 2016, it was decided we will make a Jojila tunnel, and May 2018, Honorable Prime Minister had laid the foundation stone. Now, if we see the configuration of this entire project, if we start, left of us is a Srinagar, from where we start point of the Jojila tunnel project, around 17 kilometer, part one is the road part of it. In that road part, there are series of bridges. There's a first bridge, I have written as MJB1, Major Bridge 1, 175, then followed by 140 meter. I'll be showing the videograph of all these bridges in the end of my presentation for last 7 minutes, so you can correlate in that. Then 140 meter, second major bridge, 460 meter, third bridge. Then there is a twin tunnel of 468 meters, then followed by a bridge, then followed by again a twin tunnel of around 2 kilometers, then followed by cut and cover. Then there are 8 places where cut and cover has come. After that, we start Jojila tunnel per se, which is around 13.15 kilometers. During the beginning of the session, chairperson has said it is 14 kilometer. Yes, it was designed to be 14 kilometer, but some value engineering has been gone into, some portal locations were shifted, so we have reduced the length by 980 meter, adding, saving some cost to Government of India. So these Nilgara tunnels which are there, there are 2 places, and first Nilgara tunnel is of 446 meters, then 468 meters. Similarly, second one is around 2 kilometer. The twin tunnel. Jozila tunnel is 13.15 kilometers, which is single tube bidirectional. But there is a discussion going for the second tube also to be provided. As for now, the traffic part of it is not supporting. The necessity is more important to begin with. Then followed by we can have a luxury of 2 tubes as well. Then there are major bridges, and the total length of the road in this part is around 11 kilometers. Balance is all tunnel and other structures. This is the project configuration which I have just described. This project, the authority is NHI DCL, authority's engineer is ICT, and it is on EPC mode. The design life is given 100 years, defect liability period is 5 years, and it is designed for seismic zone 4. It all started, letter of acceptance was somewhere in August 2020, and it has started on October 2020. Completion period is given 72 months. That is September 2026. We are expecting it to be completed. Total contract value is around 4,500 CR. Now coming to the sub-components and their progress. If you see, there are 4 bridges, 810 meter. In the video, you can make out the progress is not much, will be between hovering between 8% to 12%. There are Nilgara tunnels, 4 of them. They are going with a good speed. They are around 85% of the progress. Cut and cover 8 places. We can see around 50% progress has been achieved till now. Jozila tunnel is now around 20%. It is, we have done from the western part, we have done heading of around 3 kilometers, and benching is around 1.5 kilometer. Similarly, on the western part, we are touching similar 3 kilometers and 750 meters. And it has got 3 shafts, 3 vertical shafts. These vertical shafts are challenge in itself. They are 40 meter offshift to the main tunnel because of the various technical reasons. That means we going for a main tunnel, then we have a cavern of 40 meter towards western side. Two caverns are from the western side, and 1 cavern is towards the eastern side. 40 meter of them, and then we have a vertical shafts being constructed. In this vertical shaft also, if you see, one shaft is at 500 meter depth, which we have to go. The initial approach which we were taken was we will go top to bottom. We have succeeded in some places, but in shaft 1 we could not succeed, because till date we also have a snow cover of around 20-25 meter over there. So now the discussion is going on. We will go for a race chamber kind of a thing. We will have a pilot vent from the bottom to the top, and then we will increase the size so that it will not only ease out our mucking, it will also accelerate. Our project will not get delayed. Otherwise, the shaft number 2, out of 391 meters, we could achieve only 50 meter in 2 years. That is the level of difficulty, because moment you make a canopy, gantry, etc., you go inside, then again snowfall comes. So there also the modality is being discussed. We will go from bottom to top. Besides those main features, it has also got cut and cover of 2.4 kilometers, and there are catch dams for the avalanches over the cut and cover, approximately 1.5 kilometer, and air blast wall basically to mitigate the blast effect of the air when the avalanche and this takes place. Deflector dams, snow galleries of 450 meters cumulatively. If you see the cross section, this is a cross section for Nilgara tunnel, which is a tunnel where the 2 tunnels of Nilgara. Tube 1 is 468 or 446 meters, and second one is 1.9 and 1.8 kilometers. The excavation, that dia which we are cutting, is approximately 10 meters, and the finish is coming 7.5 horizontally and 5.5 vertically. The components of this is already given here. All the details, lining, theoretical excavation lines, shotcreting lining, its thickness, final lining thickness, waterproofing, then all the profiles, other gadgets are given in this, so I will not read one by one. It will be available to you. You can go through, please. Now this is a cut and cover, very interesting. We have to, this cut and cover was actually forced upon us because there was no way we could have taken any other solution. Tunnel was not possible, bridge was not this thing, road could not be maintained, then this was the only option. So 12.5 meter is the width we are actually preparing it, and 9 meter is the vertical external dimensions which are preparing it. And then we are going for a raft first, and then we are going for through a gantry casting the cover. So far out of this 2.4 kilometer, we have done 3.5 kilometer of raft we have done, and 400 meters of cover portion of this cut and cover we have already finished. This is the snow gallery concept. This snow gallery is where we are, we see we can maintain. Time we have to protect our road users from avalanches. So there is 200 meter thick beam at the top where the slab is there, and on the left side, that is we have to put some kind of a filter media where 100 meter diameter weep holes per square meter. This has been actually theoretically designed, but we have not started executing on ground as of now. The length of this snow gallery is approximately 60 meters cumulatively at 3 different places. It will be interesting to see the entire project through a drone video in the last of all these things more clear. Now this is what the air blast wall which I was talking. The total length in this project air blast wall is around 1.5 meter. If you can see, primarily it is for the blast at the time of avalanche and high velocity of the wind which is going on over there, and this deflector dams which is above the above the cut and cover areas. So some of the photographs I would like to show you before we proceed. This is the Nilgara Tunnel 1, twin tubes, unidirection. This is where I said we are touching around 85% of the progress. This is the gantry which has been used in the Nilgara Tunnel. This is Tunnel 2, finished product. If you see, there are some exposed portion of the road also which is being constructed, and the bituminous concrete which is used over there is exclusively designed for that kind of minus temperature. Polymer modified bitumen and various other layer has been designed as a performance material. Now, sir, I come to the typical cross sections of Zojila Tunnel. This is the typical cross section which we are adopting. There are two type of designs which we are following. One is with the invert, one is without invert. So as my previous speaker has said, if you have to protect your tunnel during seismic forces, if you provide an invert, it gives a better stability. But here the design, both the designs are kept in mind keeping rock or the quality of geology which you're going to encounter. So far we have got into 6 kilometer of Zojila out of 13.5 kilometer. The rock quality is of good. We have not used this inverted design part of this tunnel. Now there has been been asked why you are not gone, why there is a single bidirectional tube, because it is not good for the safety of the user. So only answer remains right now the traffic is very low. As and when we are successfully do this, the traffic will get generated, tourists will get also this thing, socio-economic changes will take place. That's why the DPR for the second tunnel has been deferred for some time. This is the cross-sectional profile. You can see 3% is the gradient which we have been uniformly adopted over there, and this is how the profile looks like. In yesterday's, one of the presenter has given aerial electromagnetic survey concept that was also carried out 4 years back before this project was conceived. Somehow that issue of aircraft, we had used Chinook helicopter, but he could not fly straight, as that is the yesterday one of the speakers said it's one of the issues, and the level of that electromagnetic component was not uniform. Although that data was useful to us, but we could not utilize to the maximum as expected earlier. Now, these are the two different cross sections which I was talking without invert slab or with invert slab. No convergence till what 6 kilometer we have gone inside has been observed till now. We also have 17 numbers of lay-by in this project, because the length of the project is huge, and we have to provide certain places where there are passing places or breakdown vehicles or for other reliefs can be given. So the dimension of this is although main tunnel is, first we are digging main tunnel 11.5 meter, then we are slashing one side by 3 meter. So we are achieving around 18 meter of the width in that part of the lay-by every 750 meter of the tunnel as we progress. Okay, so this is regarding that ventilation shaft which I was talking about. We are going 40 meter offset, and then we are going vertically. At the peak place where the tunnel is going, the total surcharge is around 900 meters, but these vertical shafts are maximum we have placed at 500 meter, 391 meter, and some 250 meters approximately. So these caverns are there, and earlier the thought process was that we will give 14 meter diameter to this vertical shaft. We will drop down our tunneling equipment from the top, and first we will address this, and after that we will use more attack points so that we can accelerate the progress. This planning could not be materialized because we could not develop our vertical shafts because of the geological, temperature, and human and machinery problems there.
Mr. Goel, only 2 minutes, time is up.
Yes, sir. So I'll go faster, but I'll request you to allow me to show that video to the audience. So I'm going fast, I'll straight away. These are some safety measures, run-of-mill solutions, fire hydrants, emergency laybys, etc., etc. This one can read it, nothing. It's all theoretical and first major bridge from Srinagar towards Baltal. Second major bridge. This video is 4 days old, so that you can correlate with the physical progress on ground. cut and cover area. These are the areas where the vertical shafts are supposed to be coming. By the planning part, it was decided that vertical shaft will use to have attack points, but actually on field, what we see, it is become impractical to do that. This is the eastern portal of Jojila Tunnel, which is Meenamag, opens towards Ladakh.
This portion is eastern side you are telling.
Yes, sir. This is from the Ladakh side, sir.
Okay. Eastern portal.
Eastern portal. Then this is the camp towards eastern portal, that is in Ladakh, Meenamag. The work has been suspended last 7 days because of the snowfall. And today in the morning we received an advisory from state administration. No vehicle should travel and nobody should move towards the mountain side because avalanche is very imminent. Thank you, sir. I finished.
Thank you, Mr. Goyal, for excellent capturing the details of Jojila Tunnel. And there was no doubt that it was long overdue because our Leh portion, Ladakh portion remains cut off for 4 or 5 months. And just Mr. Soik sitting adjacent to me, he was telling that it looks like Norway. Then I shared with him that except seas, it is like that. Anyway, thank you all of you. And now I'll open to floor for questions to speakers. Yes. Can you pass on mic, please?
Hello. Mike. Hello. Myself Piyush Singh from GeoConsult. My question is to Mr. Goyal. Goyal sir, in terms of Zojila planning, these shafts were very important for the completion of the project. And as you mentioned that so far we have not progressed much. So will it have any impact on the completion time period of the project?
Sir, very good question. Your worry is my worry. At the same time, there is always an engineering solution. Time and cost is proportional to the resources. Okay? That's why we have said we will go for a raised climber. We will have a pilot 2-meter tunnel from bottom till top, and then we will widen it. It will not only help us in demucking faster. In fact, the current issues of continuous snowfall and water coming from the top, when we are digging from the top, not able to take a muck out, that will also be obviated by that. Although we are still not out of time, 2026 or 2025 is what is our target, and we are going with a good speed, and hopefully if the contractor continue to perform and we are able to take a decision in time as an authority, we should be able to deliver this. But not only this, I would also tell you, this project of 44 kilometer also needs to be augmented, supplemented beyond Minamwak, that is towards Ladakh. For that, the DPR is also being made. After that only, it will be a seamless connectivity.
Okay.
Thank you very much.
Thank you. Yes, please.
My question is, for last 2 days we are listening about the...
sir, to whom it is address?
Address to all the speakers, all the experts.
Oh, all the speakers.
Yes.
Can you give the priority? Who should reply first? Okay, tell me the question.
So, about the various methods of investigation, execution, contract management, and how to overcome all the solutions. My point, we are going for against the nature. We are making the earth hollow. So what is the ecological, there will be any effect on ecology, and what is the thought of all the experts, professors and all that?
Okay. I think from that angle, I think Mr. Shovik is from Norway, and Norway is the country where people are very particular about the ecology and environment issue, right? And very concerned about the carbon emission and all that. Therefore, I think it will be better that you should try to give the answer.
But the question was...
His question is that we are talking about the construction of tunneling and development and all that. We are talking always technology and all that. But on the other part, what about the ecology and environment impact, adverse impact on that?
And of course, when we are considering the different alternatives, for instance, between building a bridge, a ferry, and tunnel, we also look, that is also a parameter, what impact it will have on the environment. So that is very much a part of any alternatives or any alternative discussions when we are building. What we are doing in Norway now, and this is because of the great focus now on sustainability and the environment, is that we are doing quite a lot of innovative research, bringing technologies that maybe is used in other industries into the tunnel industry. And we have several examples of that now in place in Norway. For instance, we are using recycled glass to build these technical buildings, but also a lot of the construction parts inside the tunnel. So we can use that kind of materials, and suddenly you will have a more sustainable world because of that. And when it comes to tunnels is a big polluter, especially when it comes to materials. But we have another project that is very interesting. Is we are looking into electrifying vehicles, electrifying all the machineries to also meet new environmental requirements. And We are actually, me personally, and are involved in one of these projects to analyze how we can do this and what kind of risk this will involve. Both risk on health, but also on economy, and also on the time in project, because we need to keep up also the cost efficiency. So cost is always very important in this, but in every of these projects, we always will have a better cost when we are finished. So sustainability and new solutions is always welcomed.
Thank you. From Mr. Sago, based on your experience in Japan, would you like to share something? How to take care of impact on the ecology and environment due to the tunneling activities?
Okay, thank you, Mr. Srivastava. So the ecological program is a very big issue in Japan because especially governmental official needs to explain the necessity of the necessity and the importance of the tunnel project. And because it will take a lot of money and investment and time and so on. And in Japan, so the some rare birds and some rare creatures existing around the nature. So the we set on the occasion to explain the residents and the local people during a long time before the design concept.
Thank you. Thank you, Isago.
Sir, myself, Tanveer Hussain, working in Kwan International Limited as Deputy General Manager. I am presently posted in Sivok Rangpur Railway Project. Sir, my question is that in our design,
to whom question is for whom?
Pardon, my question is for Mr. Isago.
Okay.
Sir, in our original design, rebars have been provided as reinforcement for permanent lining. But recently we have received some suggestions from some experts that we can also use steel fibers. I would like to mention here that the area where our project is falling under seismic zone 4. Okay, so shall you recommend we shall stick to rebars or shall we go for steel fibers? And also for subsequently for temporary lining, that is for short rating. In our designs we have been provided to use steel wire mesh, but here also we have received recently some suggestions that we can also use steel fibers to save time or improve our cycle time. So what are your recommendations and what do you suggest, sir, in this regard?
Okay.
Yeah.
Okay. Thank you for questions. So the steel fiber is was used mainly in Japan for the permanent lining reinforcement. It may be to avoid the small debris spawning from the tunnel linings. But recently, so that it may be it mainly used around the 2005 or 2006 around so. So because but the expressway company stopped using the steel fiber reinforcement for the permanent lining because it corrode or it erodes and something, and some brownie water spilled down to the permanent lining. So and it affects on the quality of the permanent lining concrete. So they shifted into the vinyl fiber, so the non-steel fiber. But if we need to confirm the strength, the permanent lining, so it is certainly effective for the rebar or steel fibers. So the steel fiber, but the steel fiber, the ratio of the steel fiber is up to 1% for the volume
to exert the influence for the boosting the strength. Maybe it is almost equal to the reinforcement. So the reinforcement bar is a good if the strength is we need to the very big strength, and if we small strength, so that means it is strange to say, but not so many strengths, so it may be good to use the steel fiber.
Thank you, Mr. Shah. Thank you.
Sir, one more question for Mr. Sovik. This is regarding, because the Norway have more expertise in this tunneling. So is there any specific method of construction